Hello there, and welcome to The Tired Thinker, a quiet corner where curiosity slows down and big ideas are explored gently. Tonight, we're venturing into something both fascinating and unsettling: the human brain. It's the place where every thought, every memory, and every dream lives. It tells you who you are, helps you make choices, and shapes how you see the world. But beneath that sense of control and clarity, there are darker truths, things about your brain that might make you uneasy. It can lie to you, it can rewrite your memories, it can even turn against you, all without you ever realizing it. As you watch this, billions of neurons are firing, fading and rewiring, quietly changing who you are, moment by moment. The brain feels familiar, but in many ways, it's still a mystery, one that holds secrets we don't always want to face. Before we begin, I'd love to know, where are you watching from? And what time is it in your little corner of the world? It's strange, isn't it? So many of us, scattered everywhere, each with our own private thoughts. And yet here we are, connected for a quiet moment, thinking together. If you find this kind of slow, thoughtful exploration comforting, or if you just need a soft place to rest your mind after a long day, a gentle like or subscribe helps this tired little channel find others who might need the same. Now, take a deep breath. Let's step softly into the shadows of the mind and uncover some of the most disturbing truths about the human brain. Stress is more than just feeling overwhelmed or tired. It is a physical force that can shape the brain in ways you might never notice until it is too late. Imagine a young woman named Claire. She works long hours at a job she hates. She rarely sleeps well, drinks too much coffee, and spends her nights worrying about bills. She tells herself this is normal. Everyone is stressed, right? But inside her skull, something silent and dangerous is happening. Her brain is changing, and not for the better. Deep inside the brain sits a small, seahorse-shaped area called the hippocampus. This part of the brain is crucial for memory and learning. It also helps regulate emotions. When the hippocampus works well, you can remember where you parked your car, recall a friend's birthday, and stay calm in a tough moment. But when stress becomes constant, like in Claire's case, the body produces high levels of a hormone called cortisol. Cortisol is useful in short bursts. It helps you react quickly when there's danger, like slamming on the brakes when a child runs into the road. However, when cortisol stays high for too long, it becomes toxic. It starts to damage the very brain it is meant to protect. Over weeks, months, or years of chronic stress, the hippocampus begins to shrink. This is not just a figure of speech. Brain scans show that the cells in the hippocampus actually lose connections, and some die off. As the hippocampus shrinks, memory starts to falter. Claire might forget small things at first, like where she left her keys. Later, she might struggle to focus at work or recall entire conversations. She blames herself for being careless, but the truth is her brain is under siege. The effects do not stop there. As the hippocampus weakens, another part of the brain, the amygdala, becomes more active. The amygdala controls fear and anger. It evolves to keep humans safe from predators and threats. When it becomes too active, everyday challenges start to feel like life or death situations. Claire begins to snap at coworkers and feels on edge for no clear reason. She sees problems everywhere, even in harmless comments or minor mistakes. Her world starts to look hostile because her brain has shifted into survival mode. This shift can lead to serious mental health problems. Chronic stress increases the risk of depression, anxiety, and even post-traumatic stress disorder. In severe cases, it can push someone toward thoughts of self-harm. Scientists have found that people with long-term stress often have smaller hippocampi than those who live calmer lives. This shrinkage is not just about mood or memory. It is a sign of real physical harm. The brain is an organ, just like the heart or lungs. If it suffers enough damage, it can fail. Think of it like this. Imagine leaving a light bulb on all day and all night. At first, it glows steadily. Over time, the filament inside burns out and the bulb dies. The human brain works in a similar way. cortisol keeps it switched on constantly, which wears down its delicate structures. When Claire's stress remains unbroken, her hippocampus burns out. She does not feel this happening. There is no pain, no warning signal. By the time symptoms appear, the damage may already be deep. In one study, researchers followed a group of medical students. During exam season, their cortisol levels rose sharply. Brain scans showed that their hippocampi shrank slightly after just a few weeks of intense stress. After exams ended, their brains began to recover. This shows how quickly stress can leave its mark, and how much harder recovery becomes if stress never stops. For someone like Claire, who has been stressed for years, the brain may not fully bounce back. The most frightening part is that stress can kill indirectly. A weakened hippocampus cannot regulate the body's stress response well. This leads to even higher cortisol levels, creating a vicious cycle. The heart and immune system also suffer. People under chronic stress have higher rates of heart disease, diabetes, and infections. Their bodies are constantly fighting an invisible war. Over time, this strain can lead to stroke or heart attack. In this way, the brain, through stress, can set off a chain of events that ends a life. Picture Claire 10 years later. She is only in her 40s, but she feels older. Her memory lapses are now serious. She forgets important meetings and sometimes gets lost on her way home. She often feels angry or sad without knowing why. Her doctor tells her she has high blood pressure and early signs of depression. These are not separate problems. They all trace back to the same source, a brain worn down by unrelenting stress. Stress does not always come from dramatic events. It can creep in quietly, like a slow leak in a roof. A difficult job, money worries, or family conflict can seem manageable at first, but day after day, they pile up. The body never gets a break. Cortisol stays high, and the hippocampus pays the price. Claire never saw a single moment where everything broke. Instead, it was thousands of small moments adding up, shaping her brain one thought, one worry, one sleepless night at a time. Some people believe they can simply tough it out. They see stress as a challenge to overcome through willpower. But the brain does not care about determination. It responds to chemistry, not pride. Even the strongest person cannot outthink cortisol. Without rest and relief, damage continues. Why soldiers returning from combat, caregivers looking after sick relatives, and even children in unstable homes often show similar brain changes. The source of stress may differ, but the effect on the hippocampus is the same. One evening, Claire sits in her car after work, staring at the steering wheel. She cannot remember where she planned to drive. She feels a wave of fear, then anger, then exhaustion. She does not know that inside her head, tiny structures have been shrinking for years. She does not know her amygdala is now running the show, flooding her body with signals of danger. To her, it just feels like life is getting harder. She thinks she is failing, but in truth, her brain has been fighting a battle she never saw coming. The damage from stress is silent, but its results are visible everywhere. A forgotten face, a sudden outburst, a heart attack in middle age. These are all signs of what happens when the brain turns against itself. The hippocampus does not send warnings. It simply fades, leaving behind a person who no longer remembers who they once were. When people think about aging, they usually picture wrinkles, gray hair, and aching joints. Few think about what happens inside the skull, in the soft, silent space where every thought, memory, and feeling is born. The truth is, the brain begins to change long before the body shows obvious signs of age. By your late 20s, tiny changes start to unfold. They happen quietly, without pain or warning, and they never stop. This slow unraveling is called neurodegeneration, and it is something every person experiences, whether they notice it or not. Consider a man named David. At 28, he feels strong and sharp. He remembers phone numbers without writing them down, picks up new skills quickly, and solves problems with ease. He laughs when older coworkers forget where they left their keys or struggle to recall a name. To him, that kind of forgetfulness feels far away. What David doesn't know is that his own brain has already started to lose neurons. It is happening right now, one cell at a time, and there is no way to completely stop it. The human brain is made up of billions of neurons. These cells are like intricate wiring in a massive network. They send signals to each other through connections called synapses. These connections allow you to speak, read, drive a car, or simply recognize a friend's face. When you are young, your brain builds new connections easily. It's flexible and resilient, able to repair itself after injury or stress. But as you grow older, this balance shifts. Slowly, the brain begins to lose more neurons than it replaces. This loss doesn't happen evenly. Certain areas, like the hippocampus, which handles memory, are more vulnerable. Others, like the prefrontal cortex, which helps with planning and decision-making, also show early decline. At first, the changes are too small to notice. David might pause for a second before recalling a word, or feel slightly slower when learning a complex task at work. These moments seem trivial, the kind of thing anyone might dismiss as being tired or distracted. But inside his brain, the process is steady and irreversible. Every day, thousands of neurons die. The body does not replace them at the same rate. It's like a city losing power lines one by one. The lights may stay on for years, but eventually, parts of the city go dark. Imagine David a decade later, now in his late 30s. He still feels young, but he sometimes forgets why he walked into a room. He occasionally loses track of small details at work. His brain has adjusted to the loss by strengthening other connections, a process called plasticity. This is why most people function well despite ongoing cell death. The brain is good at working around damage, hiding the cracks in its structure. But this adaptability has limits. As more neurons disappear, the effort to compensate grows harder. By the time the effects are obvious, years of decline have already taken place. Some of these changes come from natural wear and tear. Neurons are active cells. They burn energy constantly and produce waste products. Over time, this buildup damages the cells and their support systems. It's similar to how a car engine accumulates grime after years of use. The body has ways to clean up, but these systems slow with age. The result is gradual decay. In some people, this decline speeds up, leading to diseases like Alzheimer's or Parkinson's. These conditions are extreme versions of what happens to everyone on a smaller scale. Even without a diagnosis, every brain is subject to the same underlying process. David's grandmother has dementia. Watching her struggle to recognize family members frightens him. He wonders if he might face the same fate. His doctor explains that while genetics play a role, lifestyle also matters. Sleep, diet, exercise, and mental activity can all affect how quickly neurons are lost. Still, no matter how healthy David lives, he cannot stop the basic fact of decline. It's like trying to slow a river with your hands. You can divert the flow for a while, but the water keeps moving. There's another part of this story that people rarely talk about. As neurons die, the spaces they once filled don't remain empty. Other cells, like glia, move in. Glial cells are support workers, cleaning up debris and maintaining the brain's environment. When too many neurons die, glia become overworked. Sometimes they release chemicals meant to heal, but in high amounts, these chemicals cause inflammation. This inflammation, in turn, damages more neurons, creating a cycle of destruction. David cannot feel this happening. There's no pain signal, no fever to warn him. It's a silent storm inside his head. Picture a forest fire that starts small, burning just a few dry branches. If the fire stays contained, the forest survives. If the wind spreads it, entire sections of trees vanish. Neurodegeneration works the same way. A few lost neurons might go unnoticed, But as the process spreads, larger networks break down, memory falters, attention drifts, and mood shifts. Some people become irritable or withdrawn. Others lose the ability to plan ahead. David's grandmother started by misplacing her wallet, then forgot the names of her children. By the time she entered a care home, entire parts of her brain had gone dark. The cruel thing is that the decline begins long before there are any warning signs. David's first lost neurons died when he was still in his 20s. At that time, his brain had so many extra connections that the loss felt meaningless. Now, at 42, he notices the difference. It shows up when he can't remember a password he used every day or when he needs a moment to recall a coworker's name. These are not just signs of being busy or distracted. They are proof that the wiring in his brain is slowly unraveling. The changes also affect emotion. The prefrontal cortex helps regulate feelings, while the amygdala controls fear and anger. As neurons in these areas decline, emotional balance shifts. David finds himself more anxious in situations that never bothered him before. He sometimes snaps at his children over minor issues. He doesn't realize this is part of the same process that causes his memory lapses. To him, it feels like he is just tired or stressed. In reality, parts of his brain are losing control over others. This story isn't unique to David or his family. It is the story of every human brain. Some people experience it slowly, others more quickly. The pace depends on genetics, health, and environment. But the direction never changes. From the late 20s onward, the brain moves through a gradual decline. Even in someone who lives to be 100 with sharp memory, countless neurons have already vanished along the way. The brain survives by adapting, rerouting signals through surviving cells, and building new connections where it can. This resilience is why people can lose so many neurons before showing clear signs of trouble. David sits in his kitchen one night, staring at an old photograph of himself at 25. He looks at the younger man's clear eyes and confident smile. He feels a strange mix of pride and sadness. He still remembers that time, but he knows that some of the very neurons holding those memories are gone. His brain is different now, shaped by decades of tiny losses. Tomorrow, more neurons will die, just as they did yesterday. The process is silent and unseen, but it never stops. In a small apartment, a young man named Elias sat hunched over his kitchen table, staring at an empty bowl. His stomach ached, but there was no food left. It had been 3 days since his last real meal. He felt lightheaded, his thoughts slow and scattered. Hunger was all he could think about. What he didn't know was that something even more disturbing was happening inside his head. His brain, desperate to keep him alive, had started to turn on itself. The human brain is the hungriest organ in the body. Though it makes up only a small fraction of total weight, it consumes about a fifth of the body's energy. It needs a steady flow of glucose, which comes from the food we eat. When food is scarce, the body has to make hard choices. At first, it burns stored fat and muscle to keep the brain fueled. But as starvation drags on, the reserves run low. That's when the brain itself begins to take drastic action. Inside Elias's head, his neurons were struggling. Neurons are the cells responsible for everything he thinks, feels, and remembers. They are like fragile electric wires, passing signals to each other through complex networks. These cells cannot survive without energy. When the supply of glucose drops too far, neurons start to shut down parts of their own structure to conserve what little energy remains. This process is called autophagy, which literally means self-eating. It is a survival tactic, but it comes at a terrible cost. At first, autophagy is helpful. The neurons break down damaged parts of themselves, recycling the pieces to create fuel. It's like a family burning old furniture to stay warm through a freezing winter night. This keeps the brain working a little longer, even when food is nowhere to be found. But if the starvation continues, the process becomes destructive. Neurons start to consume healthy parts of themselves. Connections between cells weaken, and important networks begin to fall apart. The very tissue that makes you who you are starts to disappear. Elias didn't notice the exact moment this shift began. What he felt was a deep fog settling over his mind. Simple tasks became confusing. He forgot what day it was. At one point, he reached for his phone and couldn't remember how to unlock it. These lapses weren't just from hunger. They were signs that his brain was breaking down its own circuits. Pieces of his memory and personality were literally being dismantled for fuel. The same thing can happen under extreme stress, even when food is available. Imagine a woman named Marisol, who works in a high-pressure job. She sleeps 4 hours a night and survives on coffee and anxiety. Her body is flooded with stress hormones like cortisol. These hormones signal danger and prepare the body for a fight or flight response. In small bursts, this system is useful. But when the stress never ends, cortisol becomes toxic. It disrupts the brain's ability to regulate itself. Over time, the constant state of alarm triggers autophagy in the neurons, just like starvation does. For Marisol, the effects show up slowly. She begins to forget important meetings. She loses track of conversations halfway through. She cries without knowing why. Inside her brain, neurons are being dismantled to deal with the relentless demand for energy caused by stress. It's as if her mind is burning itself to keep functioning. This process doesn't just erase memories, it changes her behavior. When connections in the prefrontal cortex weaken, she has trouble making decisions. When neurons in the hippocampus are lost, her memory suffers, and when the amygdala grows more dominant, she feels constant fear and anger. Scientists have seen this process in brain scans and tissue samples. During long fasts, extreme dieting, or chronic stress, certain regions of the brain literally shrink. The hippocampus, which handles memory and learning, is often the first to be affected. This explains why people under heavy stress or starvation struggle to remember things or learn new skills. In some cases, these changes can be reversed with rest, food, and care. But when the process goes on too long, some of the lost neurons never return. Elias's experience grew worse with each passing day without food. His muscles were weak, and his heartbeat slowed. But it was the mental decline that frightened him most. He sat staring at the wall, trying to remember his mother's voice and failing. He began to hallucinate, seeing shadows that weren't there. This was his brain's last desperate attempt to keep him alive by using every scrap of energy it could find, even if that meant consuming itself. By the time help arrived, parts of his mind were already gone. Marisol's decline looked different, but came from the same root cause. She stayed at her desk late into the night, trembling from exhaustion, her thoughts looping endlessly. She snapped at a coworker over a minor mistake, then felt ashamed, but couldn't explain why she had lost control. Her stress had become so constant that her brain was no longer distinguishing between real threats and daily tasks. And neurons that once gave her balance and perspective were being broken down to keep her system running under constant strain. This process isn't rare. It happens quietly in countless people who live under extreme conditions, whether that's hunger, poverty, war, or relentless pressure. The brain is built to survive, but survival sometimes comes at the expense of the self. In Elias's case, the destruction was visible in his vacant stare and slurred words. In Marisol's case, it hid behind a professional smile and a calendar filled with deadlines. In both cases, their brains were making the same choice: consume a piece of themselves to keep the whole organism alive for one more day. The most disturbing part is that the brain gives no warning before this begins. There's no sharp pain or clear signal, just a gradual fading of memory, clarity, and emotional control. People often blame themselves, thinking they're lazy, careless, or weak. They don't realize their own neurons are quietly dismantling their inner world, one piece at a time. As Elias recovered with proper care and nutrition, some of his abilities returned. He could recall certain memories and follow conversations again, but there were gaps that never filled in. Marisol eventually left her job and took months to rest. Her symptoms improved, but she still noticed moments when her mind felt fragile, as if part of it had been scraped away. These lingering effects are proof of how powerful and destructive the process of self-consumption can be. The brain's drive to survive is so strong that it will sacrifice its own tissue to keep the body alive, even if that means losing parts of the person in the process. On a quiet street, a young woman named Leah kept a cat named Misty. Leah loved Misty and often let her roam outside before dinner. She never imagined that Misty could bring something into the house that might change Leah's own mind. Misty would come home with muddy paws, curl up on Leah's lap, and purr while Leah scrolled through her phone. Hidden beneath Misty's fur, inside her tiny body, lived a microscopic creature called Toxoplasma gondii. It was silent, invisible, and patient. Toxoplasma gondii is a parasite with a strange life cycle. Its natural host is the cat, but it cannot move directly from one cat to another. It needs a middle step. Small animals like mice and birds pick it up when they eat contaminated soil or food. The parasite moves into their muscles and brains, where it waits. When a cat eats an infected mouse or bird, the parasite completes its cycle and reproduces in the cat's intestines. From there, it spreads again through the cat's waste. Leah never touched Misty's litter box without washing her hands, but she didn't know how easy it was to come into contact with the parasite. Even a tiny trace of cat waste in the yard or garden can carry millions of Toxoplasma spores. When Leah made a salad from vegetables she had grown in her backyard, she didn't think twice about how clean they were. She had no idea that some of those spores had made their way onto the leaves, ready to enter her body. Once inside a human, Toxoplasma behaves differently. It cannot reproduce the way it does inside a cat, so instead, it goes into hiding. It settles in muscles, eyes, and most importantly, the brain. The parasite forms cysts that the immune system cannot fully destroy. Leah's body recognized something was wrong, but it couldn't fight the parasite completely. It was a stalemate, and the parasite was built to wait it out. At first, Leah felt nothing. Most people don't show symptoms when they become infected, but deep inside her brain, Toxoplasma was quietly influencing her behavior. In mice, this effect is dramatic. Normally, a mouse fears the smell of a cat. It will run and hide at the first sign of danger. But when infected with Toxoplasma, the mouse does something strange. It becomes attracted to the scent of cats. It moves closer instead of fleeing, making it easy prey. This behavior helps the parasite complete its life cycle because the cat eats the infected mouse, and the parasite returns to its natural host. Humans don't behave as simply as mice, but scientists have found disturbing patterns. People with Toxoplasma infections sometimes show small but measurable changes in their decisions and personalities. Studies suggest they take more risks, react more slowly to danger, and have altered levels of fear. There's also evidence linking the infection to mental health conditions like schizophrenia and depression. Leah didn't notice anything at first. Then, over several months, her friends saw changes. She began to drive more recklessly, taking sharp turns without signaling. She started gambling small amounts of money online, something she had never done before. She brushed off these changes as stress from work. But inside her brain, Toxoplasma cysts were nestled in areas that helped control fear and reward. These cysts didn't just sit quietly. They released chemicals that subtly influenced the way her neurons communicated. One night, Leah stayed up late scrolling through her phone. She came across an article about parasites and how they could change animal behavior. She laughed and told herself it sounded like science fiction. Still, the idea stuck with her. A few days later, she read another article about toxoplasma and cats. Her heart skipped a beat when she recognized the name. Misty had been acting perfectly normal, and Leah had always been careful. She tried to forget about it, but something nagged at her mind. Scientists studying toxoplasma have found surprising patterns in human populations. In some countries, large numbers of people carry the parasite without knowing it. Infected individuals tend to have subtle but consistent behavioral differences from those who are not infected. For example, some studies have linked toxoplasma to slower reaction times in drivers, which may explain why infected people are more likely to be involved in traffic accidents. Other research suggests a link to higher rates of certain mental illnesses, though this connection is still being explored. Leah noticed she had been feeling more anxious lately. Her dreams were vivid and unsettling. She began to snap at her friends over small things. It wasn't dramatic, but it was enough for her closest friend, Maria, to comment on it. "You're different lately," Maria said one evening as they walked home. "It's like you're on edge all the time." Leah laughed it off, but later, lying in bed, she felt a chill. The most unsettling thing about toxoplasma is how silent it is. The parasite doesn't make you feel sick in the way a flu virus does. It doesn't leave a clear sign like a rash or a fever. Instead, it hides and influences from the shadows. Leah had no way of knowing which of her thoughts were truly her own, and which were nudged by microscopic organisms buried deep in her brain tissue. Some researchers have studied how toxoplasma affects risk-taking. In one experiment, infected men were more likely to engage in dangerous activities, while infected women tended to be more outgoing and social. These changes might not seem dramatic, but over a lifetime, even small shifts can change the course of someone's life. Leah didn't suddenly become a different person, but the small changes added up. She began skipping safety checks at work. She started talking to strangers online and meeting them without telling anyone. Each choice seemed harmless on its own, but together, they painted a picture of someone taking more chances than before. One weekend, Maria convinced Leah to see a doctor and get tested. Leah rolled her eyes but agreed. A few days later, the results came back. She had tested positive for Toxoplasma gondii. The doctor explained that half the world's population carries the parasite, and that most people never realize it. Leah sat in stunned silence as she processed what that meant. A tiny organism, passed to her through her beloved cat, had been living in her brain and might have been shaping her decisions for months, maybe even years. On her way home, Leah stared out the bus window, replaying recent choices in her mind. She wondered how many of them were truly hers. The thought was unsettling. Misty curled up in her lap that evening, purring as if nothing had changed. But Leah couldn't shake the feeling that she wasn't entirely in control of her own mind. Somewhere inside her head, in the quiet spaces where neurons fired and memories lived, the parasite waited, patient and silent, steering her life in ways she could never fully see. Sophia sat alone at her kitchen table, staring at the same cold cup of tea she had made hours earlier. She couldn't explain why she felt so heavy inside, like a fog had settled over her thoughts. Her friends had noticed her mood shifting for months. They told her to take a vacation or get more sleep. She tried those things, but the sadness stayed. What Sophia didn't know was that part of the problem wasn't in her mind at all. It was in her gut, living deep inside her body in the form of microscopic creatures that she never thought about. The human body is home to trillions of bacteria. Most of them live in the gut, forming a complex ecosystem called the microbiome. These microbes break down food, extract nutrients, and protect against harmful invaders. For years, scientists believed their role ended there, in the stomach and intestines. But new research has revealed something startling. These tiny organisms send signals to the brain, and those signals can shape the way a person feels, thinks, and even behaves. This connection between the gut and the brain is known as the gut-brain axis. Sophia had no idea that the choices she made each day, what she ate, how much stress she carried, how little she slept, were all influencing the balance of her gut bacteria. When that balance is healthy, the bacteria help produce chemicals like serotonin, which regulate mood. In fact, most of the body's serotonin is made in the gut, not the brain. When harmful bacteria start to outnumber the beneficial ones, the production of these mood-stabilizing chemicals drops. The result can feel like anxiety, irritability, or deep sadness. Months earlier, Sophia had gone through a difficult breakup. During that time, she stopped eating well. Most of her meals came from takeout boxes filled with processed food. She also started drinking more alcohol on weekends, hoping it would take the edge off her loneliness. She didn't think much about it at the time, but inside her gut, these habits were feeding the wrong kind of bacteria. Slowly, the balance shifted. Good bacteria that thrived on fiber-rich foods began to die off. In their place, bad bacteria multiplied. This imbalance sent stress signals through her nervous system and triggered inflammation. The gut has its own network of nerves called the enteric nervous system. It communicates directly with the brain through a large nerve called the vagus nerve. This line of communication works both ways. When Sophia felt anxious, her brain sent stress signals to her gut, changing the way it moved and processed food. At the same time, the troubled gut sent distress signals back to her brain. It became a feedback loop. The worse she felt emotionally, the worse her gut health became. The worse her gut health became, the darker her mood grew. One evening, Sophia sat with her friend Claire, who worked as a nurse. Claire listened as Sophia described her lack of energy, poor sleep, and constant sadness. Claire asked about her diet and whether she'd been sick recently. Sophia admitted she had taken a strong course of antibiotics a few months ago for a stubborn sinus infection. Antibiotics are powerful. They kill harmful bacteria, but they also wipe out many of the beneficial bacteria in the gut. Claire explained that this disruption could have left Sophia's microbiome vulnerable, especially since she hadn't been eating foods that would help good bacteria recover. Sophia frowned. "Are you saying my stomach is making me depressed?" she asked, half joking. Claire nodded gently. She told Sophia about studies showing that people with depression often have different gut bacteria than those without it. In some experiments, researchers even transplanted gut bacteria from depressed individuals into healthy animals. The animals began to show signs of depression themselves, even though nothing else had changed. This suggested that the bacteria were directly influencing behavior. The idea unsettled Sophia. She thought depression came from stress or bad luck, or maybe even genetics. The thought that it might also come from invisible organisms inside her body felt strange and a little frightening. She asked what she could do, and Claire suggested starting small. Eating more whole foods like vegetables, beans, and yogurt could help restore balance. These foods fed beneficial bacteria and encouraged them to grow. Claire also mentioned probiotics, which are live bacteria found in certain foods and supplements. They could help repopulate Sophia's gut with the strains she needed most. At first, Sophia was skeptical. She couldn't imagine that a bowl of sauerkraut or a spoonful of yogurt could compete with the storm inside her mind. But she decided to try. She started cooking simple meals at home, using fresh ingredients. She added fermented foods like kimchi and kefir to her diet. Within a few weeks, she noticed subtle changes. Her digestion improved. She slept more deeply. The heavy fog that had followed her for months began to lift, just a little. It wasn't a dramatic transformation, but it was enough for her to keep going. Meanwhile, scientists studying the gut-brain connection have been uncovering more details about how this link works. Certain bacteria produce neurotransmitters, the same chemicals that brain cells use to communicate. These include serotonin, dopamine, and gamma-aminobutyric acid, or GABA, which calms the nervous system. When beneficial bacteria thrive, they help regulate these chemicals, keeping mood and behavior stable. But when harmful bacteria dominate, they release toxins and trigger inflammation that disrupts these systems. Sophia didn't know the exact species living in her gut, but she could feel their influence. On days when she slipped back into old habits, grabbing fast food, staying up late, drinking wine to cope, her mood dipped sharply. It was as if her body was trying to warn her that these choices were feeding the wrong side. She began to see her gut not as a separate part of her body, but as a partner in her mental health. Taking care of it felt like taking care of her mind. One afternoon, she met Claire for lunch. Over a plate of roasted vegetables and quinoa, Sophia described how strange it felt to think of her mood as partly controlled by microbes. Claire nodded and told her about a patient she had cared for who had severe anxiety. The patient's symptoms improved after a few months of targeted probiotic treatments. It wasn't a magic cure, but it was proof of how connected the gut and brain truly are. Sophia sat back and thought about the months she had spent trapped in a fog of sadness. She remembered blaming herself for not being strong enough to just snap out of it. Now, she understood that her struggle wasn't a personal failing. It was a sign that her inner ecosystem had been thrown off balance. That night, as she prepared dinner, she felt a quiet sense of hope. The path to feeling better wasn't easy, but it was clear. By nurturing the tiny organisms inside her gut, she was also nurturing her brain, one meal and one choice at a time. On a rainy afternoon, Daniel sat at his kitchen table, sipping coffee and reading the newspaper. His wife, Hannah, watched him from across the room. To anyone else, Daniel seemed perfectly healthy. He spoke clearly, remembered details from last week's dinner party, and even cracked jokes as he turned the pages. But Hannah knew something most people didn't. 3 months earlier, doctors had discovered a dark shadow on Daniel's brain scan, a lesion the size of a golf ball. The discovery had been an accident. Daniel had slipped while cleaning the garage and hit his head on the concrete. At the emergency room, doctors ordered a CT scan to check for bleeding. The scan showed no fresh injury, but it revealed something unexpected: a mass of damaged tissue deep inside his frontal lobe. When the doctor showed them the image, Hannah felt her stomach drop. She expected the doctor to say Daniel needed surgery or immediate treatment. Instead, the doctor shrugged slightly and said, "This could have been here for years." Daniel was stunned. How could something so serious be inside his head without him noticing? The doctor explained that the brain has an incredible ability to adapt. When one part is injured, other areas can take over its functions. This process, called neuroplasticity, allows people to keep living normally, even when parts of their brain are damaged or gone. It's why some stroke survivors relearn to speak or walk. But it also means that damage can remain hidden for years, even decades. As Hannah listened, she thought back over the past few years. She remembered little moments: Daniel forgetting where he parked the car, mixing up words now and then, or losing his temper over something small. She had chalked these things up to aging or stress. Now, she wondered if they were clues she had missed. The idea unsettled her. If Daniel's brain had been silently damaged all this time, what else might be hiding beneath the surface? Daniel tried to push the thought aside. He felt fine, so he decided not to dwell on it. But once he knew about the lesion, he began noticing small things he had ignored before. At work, he struggled to follow conversations during meetings. At home, he occasionally blanked out while telling a story, unable to recall a key detail. These moments were brief, and he could cover them up with a laugh or a quick change of subject. To everyone around him, he seemed normal. Yet he began to realize how fragile that normalcy was. There are many reasons brain damage can stay hidden. Some areas of the brain handle vital tasks like breathing or movement, so damage there shows up immediately. Other areas manage more subtle functions like planning, impulse control, or emotional regulation. When these regions are hurt, the changes are harder to see. A person might seem perfectly fine in casual conversation, but behave differently under stress or in complex situations. Daniel's lesion was in his frontal lobe, which helps with decision-making and personality. Over time, Hannah noticed small shifts in his behavior. He became more impulsive, blurting out comments he would have kept to himself before. He seemed less interested in activities he once loved, like woodworking and gardening. These changes were gradual, like water wearing away stone. If she hadn't known about the lesion, she might have thought he was just going through a phase. One evening, Daniel and Hannah visited friends for dinner. During a game of cards, Daniel made a simple mistake, mixing up the rules. Everyone laughed, but Hannah saw the flash of confusion in his eyes. Later, while driving home, Daniel admitted he hadn't been able to follow the game. "It's like there was a fog in my head," he said. Hannah gripped the steering wheel tightly, trying to hide her fear. Some cases are even more extreme than Daniel's. There are documented stories of people living full, functional lives with massive brain damage they never knew about. In one famous case, a man went to the hospital for mild leg pain. A scan revealed that most of his brain's outer layer, the cortex, was missing, replaced by fluid. Doctors expected him to have severe disabilities, but he worked as a civil servant, lived independently, and had a family. His brain had slowly adapted over the years, rerouting signals through the remaining tissue. These cases highlight how much of the brain's work remains hidden. It doesn't announce every injury with clear symptoms. Instead, it quietly reorganizes using whatever resources are left. This adaptability is both a blessing and a curse. It allows people like Daniel to keep living normally, but it also masks problems until they become serious. By the time symptoms are obvious, the damage may be extensive. Daniel's doctor recommended regular checkups to monitor the lesion. There was nothing to remove or repair, only to watch. Hannah found this frustrating. She wanted action, something concrete to fix the problem. But the doctor explained that operating could cause more harm than leaving the lesion alone. The safest path was to let Daniel live his life and intervene only if his condition changed. As months passed, Hannah became hyper-aware of every small slip Daniel made. When he forgot the name of a neighbor, she held her breath. When he misplaced his wallet, she wondered if it was a sign of decline. Daniel, meanwhile, tried to carry on as before. He went to work, watched football, and mowed the lawn. Most days, he felt normal. Sometimes, he even forgot about the shadow lurking inside his head, until a lapse reminded him it was still there. One morning, while getting ready for work, Daniel stood in front of the bathroom mirror, toothbrush in hand. He suddenly couldn't remember whether he had already brushed his teeth. He checked the sink, sniffed his breath, and still wasn't sure. The moment passed quickly, but it left him shaken. He didn't tell Hannah. Instead, he smiled at her over breakfast and acted like everything was fine. The strangest part for Daniel was knowing that others saw him as perfectly healthy. When he met friends for lunch or chatted with neighbors, they treated him like the same person he had always been. They couldn't see the tiny cracks forming beneath the surface. Even Hannah, who knew the truth, struggled to reconcile the man in front of her with the dark spot on the scan. Late one night, Hannah sat beside Daniel while he slept. She studied his face, searching for signs of change. He looked peaceful, like any other husband sleeping beside his wife. Yet inside his skull, unseen and silent, the lesion remained. It had been there for years, shaping his behavior in ways too subtle to notice, hiding in the folds of his brain like a secret neither of them fully understood. It started with little things. Margaret would lose her keys, misplace her glasses, or forget the name of a neighbor she had known for years. At first, she laughed it off. "Getting older," she told her daughter, trying to make light of it. Her family teased her about her forgetfulness, and she played along. Deep down, though, she felt uneasy. Something didn't feel right. The gaps in her memory weren't just occasional slips. They were becoming more frequent, and sometimes she found herself struggling to follow a conversation she would have understood easily before. One morning, Margaret woke up feeling dizzy. The room spun for a few seconds, then settled. She sat on the edge of the bed, breathing slowly until the sensation passed. She didn't mention it to anyone. Later that day, she noticed her right hand felt clumsy while she made lunch. The knife slipped, and she nearly cut herself. By evening, the feeling was gone. She shrugged it off and decided she must have been tired. What Margaret didn't know was that she had experienced a silent stroke, a tiny disruption in blood flow to her brain that had killed a cluster of neurons. It happened without pain, without clear warning, and without leaving a trace she could easily see. A stroke usually brings to mind dramatic scenes, slurred speech, drooping faces, an ambulance racing to the hospital. Silent strokes are different. They happen quietly, often while a person is asleep or going about their day. The damaged area is usually small, so the body compensates. The person may feel fine within minutes or hours, but inside the brain, the damage remains. Millions of people experience these micro-strokes each year without realizing it. Over time, they add up. Each one leaves a small scar, like a footprint in sand. One footprint means little. Hundreds can change the entire landscape. Margaret's first silent stroke went unnoticed, but it wasn't the last. Over the next year, she had several more. Some were so minor, they caused no obvious symptoms. Others left subtle marks, brief moments of confusion, a missed step on the stairs, a word she couldn't quite recall. She didn't connect these incidents, and neither did her family. It wasn't until Margaret's daughter, Rachel, visited one afternoon and found her mother struggling to remember how to use the television remote that alarm bells rang. At the doctor's office, Margaret underwent a brain scan. The image revealed small white spots scattered across her brain. The doctor pointed to them with a pen. "These are areas of old damage," he explained. "They're caused by silent strokes." Margaret blinked at the screen, trying to make sense of what she was seeing. She had never been in the hospital for a stroke. She had never felt like she was in danger. Yet, the proof was there, undeniable and permanent. The doctor explained how these strokes happen. The brain needs a constant supply of blood, carrying oxygen and nutrients. If a tiny blood vessel becomes blocked, even for a few seconds, the surrounding neurons begin to die. In a typical, larger stroke, the loss is dramatic and symptoms appear immediately. With a silent stroke, the area affected is so small that other parts of the brain quickly take over the lost function. This is why Margaret didn't notice anything severe at first. Her brain adapted, covering up the damage like a skilled repair crew patching holes in a wall. But each patch comes at a cost. Over time, as more microstrokes occur, the brain has less and less reserve. Tasks that were once automatic become difficult. Memory starts to fray. Balance and coordination weaken. People often mistake these signs for normal aging, but they're actually the result of repeated, hidden injuries. The process is slow and relentless. By the time it becomes obvious, much of the damage is already done. Margaret sat quietly while the doctor spoke. She thought about the moments she had brushed off, the dizziness, the clumsy hand, the sudden blankness in the middle of a sentence. They hadn't been random quirks. They had been warnings she hadn't known how to read. Rachel squeezed her mother's hand, her face pale. She asked the doctor what could be done. He explained that preventing future strokes was the main goal. Blood pressure needed to be controlled, cholesterol managed, and regular exercise added to Margaret's routine. These steps wouldn't reverse the damage, but they could slow the decline. As they drove home, Rachel couldn't stop thinking about how invisible the danger had been. Her mother had walked around with multiple brain injuries, completely unaware. She thought of how easily it could have been missed forever. Millions of people live like that, she realized, going about their days while silent strokes gradually steal pieces of them. Margaret began paying more attention to her body. One afternoon, while reading a book, she noticed her vision blur for a few seconds. It cleared quickly, but instead of ignoring it, she told Rachel. They went to the doctor, who confirmed it was likely another small stroke. Because they caught it early, adjustments were made to her medications. Margaret felt a strange mix of fear and relief. Fear, because she now understood how fragile her brain was, and relief, because for the first time, she wasn't completely in the dark. Rachel started to see her mother's world differently. She noticed how Margaret sometimes hesitated before answering questions, or lost her train of thought mid-sentence. These moments were subtle, but clear once she knew what to look for. She realized how easily silent strokes could be mistaken for forgetfulness or mood swings. The thought unsettled her. If they hadn't discovered the truth when they did, Margaret might have slipped further into decline without anyone knowing why. Months passed. Margaret made changes to her diet and began walking each morning. She kept a small notebook where she wrote down anything unusual: a moment of confusion, a sudden headache, a lapse in memory. This journal helped her track patterns and gave her a sense of control. It also gave Rachel a way to see how her mother's condition evolved. Some weeks were quiet, other weeks brought small scares. Each entry was a reminder of the silent battles happening inside Margaret's head. One evening, Rachel sat beside her mother as they looked through an old photo album. Margaret pointed to a picture of herself as a young woman holding Rachel as a baby. "I remember that day," she said softly. Then her brow furrowed. "At least I think I do." Rachel placed her hand over her mother's. The memories were still there, scattered like puzzle pieces, but each silent stroke had taken a few more pieces away. For Margaret, every day felt like a test. Would she wake up clear-headed, or would she find another piece missing? There was no way to know. The strokes came without warning, invisible and quiet, leaving only faint traces behind. The world saw an elderly woman moving through her daily routines, smiling at neighbors and chatting with her daughter. No one saw the hidden damage inside her skull or the slow erosion of her mind. Only Margaret and Rachel understood how fragile it all truly was. Ethan had always been known for his calm, steady nature. Friends described him as the kind of person who thought before he spoke and kept his cool even in heated situations. That all changed one rainy evening when his car slid on a slick patch of road and struck a tree. The airbags deployed and his head slammed hard against the window. At the hospital, doctors diagnosed him with a mild concussion. They told him to rest for a few days and assured him he would recover fully. Ethan believed them. After all, it wasn't a severe injury. He didn't lose consciousness for long, and the scans didn't show any bleeding. The first week, he felt dizzy and tired. Bright lights bothered him, and he had headaches that came and went. These symptoms were expected, and he wasn't too worried. But as the weeks passed, something more unsettling began to surface. Small things started to feel different. Ethan noticed that he was more irritable than before. A simple question from his girlfriend, Claire, could spark an argument. At work, he snapped at a coworker over a minor mistake, something he never would have done before the accident. At first, Claire thought he was just stressed from the crash and the insurance headaches that followed. But she couldn't ignore how his personality seemed to shift. He had always been patient, yet now he acted on impulse. He made decisions without thinking them through. One night, he bought an expensive set of speakers online without consulting her, even though they had been saving for a vacation. When she asked why, he shrugged and said, "I just felt like it." Inside Ethan's skull, the concussion had set off a chain reaction. When the brain experiences sudden force, like in a car crash or a sports injury, the soft tissue moves inside the hard shell of the skull. This movement stretches and damages neurons, the cells responsible for carrying signals. Even if scans don't show bleeding, microscopic damage occurs. Connections between neurons are disrupted, especially in the frontal lobe, the part of the brain that controls mood, decision-making, and impulse control. This kind of damage isn't always obvious right away. The brain has ways of compensating, rerouting signals to keep things running. But those reroutes are slower and less efficient. In Ethan's case, his thoughts felt foggy. He couldn't explain why he said or did certain things. To him, it felt like life had become slightly out of focus, though he couldn't put it into words. Claire noticed changes in other areas too. Ethan had trouble sleeping, often staying up late and pacing the living room. He seemed anxious and restless, yet he denied feeling worried. Sometimes he laughed at things that weren't funny, or he grew silent and withdrawn for hours. These swings left Claire confused and hurt. She missed the man she had known, the one who used to comfort her with steady words and a calm voice. One evening, they attended a small gathering with friends. During a conversation, Ethan interrupted someone mid-sentence and began speaking loudly, dominating the discussion. His friends exchanged surprised glances. Afterward, Claire gently told him that his behavior had been out of character. Ethan frowned. "I didn't notice," he said. He seemed genuinely puzzled, as if he couldn't understand what she meant. The frontal lobe's role in self-awareness is crucial. When it's injured, a person may not realize their behavior has changed. To others, the differences are glaring. To the injured person, everything feels normal. This mismatch creates tension and misunderstanding. Ethan thought Claire was overreacting, while Claire felt like she was living with a stranger. As weeks turned into months, the effects became more entrenched. Ethan started forgetting small things, like where he left his wallet or whether he had paid a bill. At work, he missed deadlines and struggled to focus during meetings. His boss, unaware of his concussion, assumed he was distracted or unmotivated. The truth was that his brain's ability to organize and prioritize had been altered. Even a single concussion can cause lasting changes. While many people recover fully, some experience lingering effects known as post-concussion syndrome. These can include mood swings, trouble concentrating, memory lapses, and personality shifts. The damage may not heal completely because neurons don't regenerate the way other cells in the body do. Instead, the brain tries to adapt, but the new pathways it creates aren't always as strong as the originals. Ethan's doctor explained this during a follow-up appointment. He compared the brain to a network of roads. After a concussion, some of the main highways are damaged. The brain builds detours, but these back roads are slower and less direct. Over time, traffic jams, confusion, impulsivity, poor memory become common. Hearing this made Claire realize how invisible the injury truly was. To the outside world, Ethan looked fine. There were no casts, no scars, nothing to show that anything was wrong. But beneath the surface, his brain was working harder than ever just to keep up. Ethan struggled with guilt. He didn't like the person he was becoming. He saw the hurt in Claire's eyes when he lashed out or forgot something important. But he couldn't simply will himself to change. His reactions were automatic, driven by damaged circuits he couldn't control. This lack of control frustrated him and deepened his anger. One evening, after a particularly tense argument, Claire suggested they see a therapist who specialized in brain injury. During their first session, the therapist asked Ethan to describe how he felt since the accident. He hesitated, then said, "It's like my emotions are closer to the surface now. I get mad faster, sad faster. I don't always know why. It's like someone else has their hands on the controls." The therapist explained that this was common after head trauma. the parts of the brain that regulate emotions can be weakened, while the primitive, reactive parts remain strong. It's like losing the brakes on a car while the engine keeps running at full speed. Hearing this gave Claire a measure of understanding. She realized that Ethan's changes weren't deliberate. They were symptoms of an injury, just as real as a broken bone, even if they were invisible. Recovery was slow. Ethan started cognitive exercises to rebuild his focus. He kept a journal to track his moods and impulses. Some days felt like progress, others like setbacks. There were moments of hope, like when he caught himself before snapping at Claire, and moments of despair, like when he forgot a close friend's birthday and saw the hurt on their face. Over time, the shifts in Ethan's personality became less extreme, but they never fully disappeared. The concussion had left its mark, reshaping him in ways he couldn't undo. The man who emerged was still Ethan, but with sharper edges and a quicker temper. Claire had to learn to love this new version of him, while Ethan had to accept that a single moment, a crash on a rainy road, had permanently altered the way his mind worked. Lena sat on a park bench, staring at the path in front of her. The evening sun cast long shadows, and the air smelled of damp earth after a brief rain. She was waiting for a friend who was late, and as the minutes passed, her mind began to wander. A sudden rustle in the bushes made her flinch. Her heart raced, her muscles tensed, and her breath quickened. It was only a squirrel darting past, but for a split second, Lena was certain something dangerous was hiding there. She laughed nervously at herself, though the unease lingered. What Lena didn't realize was that her brain wasn't built to see the world as it truly is. It was built to keep her alive. Thousands of years ago, when humans lived in forests and open plains, mistakes could mean death. If an ancestor heard the sound and assumed it was just the wind when it was really a predator, that mistake could end their life. But if they assumed every rustle was a threat, even if they were wrong most of the time, they stayed alive long enough to pass on their genes. The brain learned to favor survival over truth. It would rather make a false alarm than miss a real danger. This is why Lena's heart raced over a squirrel. Her body reacted as if there was a wolf, ready to pounce, because the cost of overreacting is low compared to the cost of underreacting. The brain doesn't care if the story it tells is accurate. It only cares if that story keeps you breathing. Lena's friend Jordan finally arrived, apologizing for being late. As they walked, Jordan brought up a disagreement they'd had the week before. Lena felt her cheeks flush. In her mind, she replayed the argument, convinced she remembered every detail correctly. Jordan, however, recalled it differently. Both of them were certain they were right. Neither was lying. Their brains had simply rewritten events to protect their own sense of self. Memory is not like a video recording. Each time a memory is recalled, the brain edits it slightly, emphasizing some details and erasing others. It fills in gaps with guesses so seamless that they feel real. This process helps people maintain coherent stories about who they are. If those stories are comforting or useful, the brain will bend the truth to keep them intact. It's not concerned with facts. It's concerned with survival of the self. Lena's version of the argument painted her as calm and reasonable, while Jordan's cast her in a harsher light. These different memories weren't about what truly happened. They were about protecting each person's identity and place in their relationship. The truth was slippery, shaped by the brain's need to defend against guilt or shame. Later, as they sat on a bench eating sandwiches, Jordan admitted to feeling anxious about work. His boss was demanding, and he constantly feared making a mistake. Lena reassured him, saying most of his worries were probably in his head. She wasn't wrong. The brain is wired to see threats, even when none exist. This is why people imagine worst-case scenarios or feel nervous before giving a speech. In ancient times, this kind of heightened vigilance kept humans alert to predators and rival tribes. Today, the same system fires off in response to emails and deadlines. The danger isn't real, but the body reacts as if it is. That night, Lena thought about her own fears. She often worried about what others thought of her. replaying conversations and scanning for signs of rejection. Rationally, she knew most people weren't scrutinizing her, but her brain didn't care about rationality. Social rejection once meant exile from the group, which could be deadly for early humans. To prevent that fate, the brain evolved to treat even small social slights as life-threatening. Lena's constant self-doubt wasn't a flaw. It was a survival mechanism running on outdated settings. The next day, Lena and Jordan went hiking. As they crossed a narrow bridge over a stream, Lena felt a flash of vertigo. Her mind pictured herself slipping, falling, breaking bones. She gripped the railing tightly, even though she was perfectly safe. The image had come unbidden, as if her brain wanted to scare her. In a way, it did. Fear is one of the brain's most powerful tools. By exaggerating danger, it pushes people to act cautiously. The picture of herself falling wasn't a prophecy. It was a lie designed to keep her steady on the bridge. Jordan, walking ahead, didn't seem bothered. He joked about the water below, but Lena stayed tense until they reached the other side. Once her feet were back on solid ground, she felt foolish for being so scared. She didn't realize her fear had served its purpose perfectly. She had crossed carefully because her brain convinced her she might die if she didn't. The brain's talent for distortion goes beyond fear. It can also create hope when hope is irrational. When people face overwhelming odds, their brains often generate optimism that defies evidence. A patient battling a severe illness might believe wholeheartedly in their recovery, even when doctors give grim news. This belief can reduce stress and boost the immune system. In this way, the lie becomes a tool for survival. The body fights harder because the mind believes there's a reason to fight. Lena once saw this in her grandfather. He had been diagnosed with a serious heart condition, yet he spoke with unshakable confidence about seeing his grandchildren grow up. Doctors were amazed by how long he lived. Lena now wondered if his optimism had been partly manufactured by his brain, a defense against despair. On their way back from the hike, Lena and Jordan passed a billboard advertising a weight loss program. The image showed a perfectly sculpted body. Lena felt a pang of inadequacy, even though she knew the photo was edited. Her brain compared her to the idealized image automatically. In the past, this kind of comparison helped humans gauge their social standing within a group. A higher status meant more protection and better chances of survival. Today, the same instinct drives people to seek likes on social media and chase unattainable beauty standards. The comparisons are no longer useful, but the brain clings to them anyway. That night, Lena lay in bed, thinking about how much of her life was shaped by stories her brain told her. Some of those stories were comforting, like the belief that her friends loved her. Others were frightening, like the imagined fall on the bridge. She realized her brain didn't seem to care whether these stories were true. It only cared whether they kept her safe, connected, and motivated to keep going. When she closed her eyes, Lena saw flashes of moments from the day: the rustling bushes, the argument with Jordan, the bridge, the billboard. Each image carried its own small lie, woven seamlessly into her perception. She drifted to sleep, knowing her brain would keep spinning these illusions, day after day. Not to deceive her out of malice, but to protect her, even if it meant hiding the truth. Mark always thought of himself as a logical person. He worked as an accountant, spent his days surrounded by numbers, and prided himself on making calm, careful decisions. Friends came to him for advice because he never seemed to lose his temper or act on impulse. But one night, while driving home from work, something happened that showed him how thin that layer of control really was. It was late, and the streets were quiet. As Mark waited at a red light, a car sped through the intersection, missing his bumper by inches. The driver honked and shouted something out the window. Before Mark had time to think, his hands gripped the steering wheel, his heart pounded, and a surge of heat rushed through his chest. Without realizing it, he yelled back, his voice raw and loud. When the light turned green, he sped after the car for half a block before slamming on the brakes. As he sat there, shaking, a wave of confusion hit him. Why had he reacted that way? That wasn't him, or at least it wasn't the version of himself he knew. Deep inside Mark's skull, Far beneath the surface, where rational thought happens, ancient circuits had taken over. These structures, like the amygdala and hypothalamus, evolved long before humans lived in cities or drove cars. Back then, survival depended on quick, automatic reactions. If a predator lunged from the bushes, there was no time to carefully weigh options. The body had to respond instantly: fight, flee, or freeze. These reactions were so essential that evolution built them into the deepest parts of the brain. They still sit there today, waiting for signs of danger, ready to override calm reasoning if needed. Mark's reaction at the intersection wasn't a choice, it was a takeover. His amygdala detected a threat, the near collision, and flooded his system with signals. His heart raced because adrenaline surged through his bloodstream. His muscles tensed, preparing for action. His prefrontal cortex, the part of the brain responsible for rational thought, barely had time to catch up. By the time it did, Mark was already shouting and chasing the other car. It felt like he had lost control, because in a very real way, he had. Later that night, Mark sat at his kitchen table, replaying the event in his mind. He remembered the look on the other driver's face, the pounding in his chest, the way his vision had narrowed to focus only on the car ahead. It frightened him. He liked to think of himself as someone who made decisions based on facts and logic. But in that moment, his ancient survival systems had taken command, and his carefully built sense of self had been pushed aside. This wasn't the first time Mark's primitive circuits had taken over. He thought back to a presentation he'd given at work a few months earlier. Standing in front of a room full of colleagues, his palms had grown sweaty, his mouth dry. His voice shook despite his preparation. There had been no real danger in that room, yet his body had reacted as if a predator were stalking him. The fear of public speaking, Mark now realized, wasn't about words or slides. It was about the deep brain interpreting a group of staring faces as a threat to his safety and status. These ancient circuits don't distinguish between modern stress and ancient danger. To them, an angry boss is no different than a rival tribe leader, and a failed presentation feels like exile from the group. Back in the distant past, exile could mean death. The brain still carries that memory, even if the world has changed. Mark's friend Julia had experienced this in another way. She had been in a minor car accident the year before and walked away unharmed. But every time she got behind the wheel afterward, her heart pounded and her hands trembled. She knew logically that driving was safe. She understood the statistics, yet her body reacted as if every trip was a direct threat. Julia's deep brain circuits had learned to associate driving with danger. No amount of reasoning could erase that memory. One evening, Mark and Julia met for coffee. As they talked, Julia described how frustrating it was to feel fear she couldn't control. Mark told her about his outburst at the intersection. They realized they were both grappling with the same problem. The ancient parts of their brains didn't care about logic. These circuits were built for a world of predators and survival, not traffic lights and office politics. Mark began to notice how often these primitive responses shaped his daily life. When he scrolled through the news and saw alarming headlines, his pulse quickened. When a coworker criticized his work, anger flared before he could stop it. Even when he opened the fridge late at night and reached for leftover cake, it wasn't just a craving for sugar. It was an ancient drive for high-calorie food, a survival strategy left over from a time when meals were scarce and uncertain. He started to see himself differently. The logical, careful Mark was still there, but beneath him was another Mark, a much older one. This older version didn't think in words or numbers. It thought in impulses, reactions, and instincts. Most of the time, the two Marks coexisted peacefully, but when stress spiked, the older Mark could seize control in an instant. One Saturday, Mark went hiking in the woods. As he walked along a narrow trail, a stick cracked loudly behind him. Before he could even turn his head, his body froze. His breath caught, his muscles tightened. It was only another hiker, smiling and waving, but Mark's body had already gone through the entire sequence of a fight or flight response. The speed of it amazed him. His ancient brain hadn't waited for confirmation. It had acted first and asked questions later. This experience stayed with Mark. It showed him how much of his life was guided by forces he couldn't see. These deep circuits had evolved to keep his ancestors alive, and they still operated with the same urgency. They didn't care about whether his reaction was appropriate in modern society. They didn't care about embarrassment, reputation, or rational explanation. Their only job was survival. Mark began paying attention to these moments. When he felt anger, fear, or sudden desire, he paused and asked himself which part of his brain was in charge. Sometimes, just naming the feeling helped him regain control. Other times, he had to wait for the surge to pass, knowing his rational mind would return once the ancient circuits settled down. Over dinner one night, Julia shared that she was trying the same thing. She had started driving short distances again, focusing on breathing steadily when her fear spiked. It didn't erase the primitive response, but it gave her space to choose her actions rather than be swept away by them. Mark realized that no matter how modern the world became, the old brain would always be there, humming quietly beneath the surface. It wasn't his enemy. It was a part of him, shaped by countless generations of survival. But it was also a reminder that reason and logic sit on top of something much older, something that can take control without warning. When the stick cracked in the woods, when the car nearly hit him, when his voice shook before a crowd, it wasn't weakness or failure. It was the echo of an ancient past, still alive inside him, guiding him through a world that had long since moved on. Adam always thought of himself as a calm person. He avoided fights in school, walked away from arguments, and prided himself on never raising his voice. His friends called him the peacemaker because he was the one who smoothed over conflicts. But one night, while standing in line at a crowded gas station, something inside him shifted. It was late, and the place was packed. People were tired and impatient. A man behind Adam bumped into him and muttered something under his breath. At first, Adam ignored it. Then it happened again, harder this time, and the man shoved past him. Before Adam could think, his body reacted. His jaw tightened, his fists clenched, and a hot rush of anger surged through him. He spun around and shouted. His voice was louder and harsher than he'd ever heard it. The man shouted back. For a moment, Adam felt ready to swing. The clerk yelled at them to calm down, and the moment passed. Adam walked to his car trembling, his heart pounding so hard it hurt. He couldn't believe what had just happened. He wasn't a violent person, so where had that rage come from? The answer lay deep inside his brain. Long before humans lived in cities or stood in gas station lines, they had to fight to survive. Resources were scarce. Rivals threatened food, mates, and safety. Those who hesitated often didn't live long enough to pass on their genes. Over thousands of generations, the brain developed specific circuits for aggression. These circuits live in primitive structures like the amygdala and hypothalamus. They sit quietly most of the time, but under certain conditions, fear, frustration, or threat, they can snap into action. Adam's outburst wasn't just about the man bumping him. His brain perceived it as a challenge, a potential threat. When that happened, his body flooded with stress hormones, like adrenaline and cortisol. Blood rushed to his muscles. His vision sharpened, and his focus narrowed to the man in front of him. Rational thought, handled by the prefrontal cortex, shut down. In that moment, Adam wasn't carefully weighing his options. He was reacting, just like his ancestors did when they faced danger in the wild. Later that night, Adam sat at his kitchen table, staring at his hands. He remembered how they had curled into fists without him telling them to. The speed of it frightened him. It felt as if someone else had taken control of his body. The truth was, in a way, someone had, an older version of himself, shaped by evolution, designed to keep him alive no matter the cost. Adam started noticing smaller moments of aggression in his daily life. When a driver cut him off in traffic, his pulse spiked. When his boss criticized him unfairly, he felt heat rise in his chest. Most of the time, he managed to hold back, but the feeling was there, ready to erupt. He realized that violence wasn't just something other people did. It was inside him, waiting for the right trigger. He thought of his brother, Jason, who had served in the military. Jason once told him about a fight that broke out among soldiers during training. It hadn't been over anything important, a misunderstanding about gear. But in seconds, calm men turned into combatants, fists flying, voices hoarse with rage. Jason said it was like a switch flipped. Adam understood now what his brother meant. Scientists have studied these switches. In experiments with animals, they found that stimulating certain brain regions with tiny electrical currents can instantly trigger aggression. A mouse that had been grooming itself peacefully will suddenly attack another mouse nearby. When the current stops, the aggression fades. This shows how deeply wired these pathways are. Humans have similar circuits. We can't escape them because they're part of what makes us human. Adam's coworker, Maria, experienced this during a stressful project at work. The team was under pressure to meet a deadline, and tempers ran high. Maria prided herself on being professional, but one afternoon, when a teammate dismissed her idea, she snapped. She slammed her hand on the table and yelled. Later, she felt ashamed and confused. She told Adam she didn't know where the reaction came from. Adam didn't say it out loud, but he knew. Stress had lit up her ancient aggression circuits. Stress plays a huge role in activating these pathways. When resources feel scarce, whether it's food, money, or time, the brain interprets it as a survival threat. It doesn't distinguish between a modern office and a prehistoric hunting ground. Under high stress, the rational parts of the brain lose influence. The primitive circuits take over, ready to fight for survival. Adam saw this in himself one evening when he came home late and hungry. He opened the fridge and found that his roommate had eaten the last of his leftovers. The anger that flared in him shocked him. For a moment, he wanted to slam the fridge door and shout, even though it was just food and easily replaced. He caught himself and laughed, but the intensity of the feeling stayed with him. These reactions aren't just emotional, they're physical. When aggression pathways activate, the body shifts into battle mode. Heart rate increases, blood flows to the limbs, and breathing quickens. It's the same response our ancestors used to fight off threats. In modern life, the threat might be a rude stranger, an unfair boss, or an empty fridge. The brain doesn't care about context. It reacts the same way. Adam began to see how violence wasn't only about crime or war. It was present in small, everyday moments, in arguments, slam doors, sharp words. These were controlled, socially acceptable expressions of the same ancient force. He realized that civilization hadn't erased violence. It had only layered rules and norms over it, like a thin sheet of glass over a roaring fire. One weekend, Adam and Jason went hiking together. As they walked through the forest, Jason pointed to a fallen tree and said, "Imagine living out here thousands of years ago. Every sound could mean danger. You'd need to be ready to fight or run at any second." Adam nodded, thinking about his outburst at the gas station. He realized that his reaction hadn't been about that moment alone. It had been about thousands of years of evolution, preparing him to defend himself. Later, as they sat by a stream, Jason told Adam about a moment in combat when he had to act without thinking. "If I'd stopped to reason it out, I might not be here," Jason said. "That part of the brain, the old part, it saved me." Adam understood then that these circuits weren't evil or good. They were simply ancient tools. Sometimes they protected. Sometimes they caused harm. What mattered was recognizing when they were in control. As the sun set and the forest grew dark, Adam felt a strange calm. He couldn't erase the aggression inside him, but he could acknowledge it. He could see it for what it was, a deep, primal part of himself, ready to rise in moments of stress. A shadow from the past, still alive in the present. Mara sat on the edge of her bed, phone in hand, staring at a photo on the screen. It was her boyfriend, Lucas, laughing with another woman at a party she hadn't been invited to. Her stomach twisted. A hot wave rose through her chest, sharp and overwhelming. She couldn't stop looking at the woman's hand on Lucas's arm, the way he leaned toward her. Mara told herself she trusted him, but the feeling inside her wouldn't listen. It wasn't just anger. It was something deeper, older, and harder to control. She set the phone down and pressed her palms against her eyes. She felt foolish for reacting so strongly, yet she couldn't shake the sensation that something precious was under threat. That was jealousy at work, though Mara didn't know it in that moment. It felt personal, like it belonged only to her and her relationship. In truth, jealousy was much older than Lucas or the woman in the photo. It was older than Mara herself. It was a force built into the human brain over thousands of years, designed to guard what people value most: partners, families, and resources. Long before cities, phones, and social media, humans lived in small groups where survival depended on cooperation and loyalty. A betrayal, whether romantic or social, could mean losing food, protection, or the chance to have children. For our ancestors, losing a partner wasn't just heartbreaking. It could mean the end of their genetic line. Over generations, the individuals who reacted strongly to threats, who fought to protect their partners and drove away rivals, were more likely to pass on their genes. Their emotions became part of the human blueprint. Mara didn't know any of this as she sat there, her pulse racing. She only knew that the thought of Lucas leaving her filled her with panic and rage. She imagined him laughing with the other woman, touching her the way he touched Mara, and a deep, almost physical pain spread through her body. It wasn't logical. Lucas hadn't done anything wrong, and Mara had no proof of betrayal. But jealousy doesn't need proof. It only needs the hint of danger. The same night, across town, a man named Victor sat in a dimly lit bar. He was hunched over his drink, watching a group of men laugh loudly at a nearby table. They were celebrating a new business deal, clinking glasses and talking about their profits. Victor felt a bitter, burning hatred rise in him. Those men had what he wanted: success, influence, respect. In the modern world, hatred often looks like anger at strangers or rivals. In the past, it helped humans compete for scarce resources. A man who hated his rival would fight harder to claim food, shelter, or status. The ones who didn't feel that drive were pushed aside. Victor gripped his glass tighter. His rational mind told him these men hadn't hurt him personally. They were just enjoying their night, but another part of his brain didn't care about logic. That older part saw only competition. To it, the success of others was a direct threat to his survival. Hatred flooded through him, a primitive signal urging him to act, to take what he needed, to eliminate the competition. Back in Mara's apartment, Lucas returned home, tired and smiling, unaware of the storm brewing inside her. When he greeted her, Mara's voice came out sharp and accusing. Lucas looked stunned. He tried to explain, but Mara's jealousy twisted his words into lies. She heard every hesitation, every pause as proof that he was hiding something. It wasn't that Mara wanted to hurt him. It was that her brain believed it had to protect her relationship at all costs. The fear of losing him was so strong that it drowned out reason. Jealousy has always been a double-edged sword. In the past, it kept families together and ensured children were cared for. A jealous parent was more likely to stay invested in their partner and offspring. But in modern life, those same instincts can backfire. They lead to fights over text messages and imagined betrayals. The brain doesn't understand the difference between a real threat and a false alarm. It reacts as if both are equally dangerous. Lucas raised his hands, trying to calm Mara. He told her about the party, naming everyone who was there. He promised her nothing had happened. Slowly, her breathing eased, though the knot in her chest remained. Later, alone in the bathroom, Mara stared at her reflection. She hated how jealousy made her feel, weak, out of control. Yet she also knew that it was powerful. It had pushed her to fight for Lucas, to guard what she saw as hers. Across town, Victor left the bar and walked home through the cold night air. His hatred still simmered. He replayed old memories of times when others had taken opportunities from him. Each replay added fuel to the fire. Hatred is sticky that way. It lingers, giving people the energy to keep competing. For early humans, this was useful. A hunter who hated a rival would stay alert and aggressive, ready to seize the next chance. Today, it often causes endless grudges and bitter rivalry that never truly end. Victor reached his apartment and collapsed into a chair. He felt drained but restless, as if his body wanted to act but didn't know how. That was the legacy of his brain's ancient wiring. It prepared him for battle, but in a modern world, there was no battle to fight. The energy had nowhere to go. The next morning, Mara and Lucas sat at the kitchen table, silent. Lucas stirred his coffee without looking at her. Mara wanted to explain why she had reacted the way she did, but she couldn't find the words. How could she tell him that her anger wasn't really about him at all? It was about a deep, primitive fear of loss, one she couldn't reason away. Later that week, Victor passed the same group of men on the street. This time, they didn't notice him. He felt the old surge of hatred, but he kept walking, jaw tight, hands shoved into his pockets. He wondered why he felt so threatened by people he barely knew. The answer lay deep inside his skull, in circuits shaped by countless generations of struggle. Jealousy and hatred feel personal, but they are ancient tools. They push people to protect their partners, their families, and their resources. They can be destructive, tearing relationships apart and fueling conflicts that seem senseless. Yet they exist because long ago, they helped humans survive. As Mara lay in bed that night, she reached for Lucas's hand. She didn't fully understand why her fear and anger ran so deep. She only knew that losing him felt like losing part of herself. And somewhere in the quiet spaces of her mind, her brain kept watch, ready to sound the alarm at the first sign of danger, just as it had for countless lifetimes before. Noah stood in the grocery store aisle, staring at two brands of cereal. He picked up one box, read the label, then switched to the other. In his mind, he believed he was weighing the options carefully, making a thoughtful choice. After a few seconds, he reached for the box on the right and dropped it into his cart. To him, that moment felt like free will, the act of choosing. But in truth, the decision had already been made before he was aware of it. Scientists have studied this exact process. In one famous experiment, people were asked to press a button whenever they felt like it, while their brain activity was measured. The researchers found something surprising. The brain showed clear signs of preparing to act several hundred milliseconds before the person felt the urge to move. In other words, the body was already on its way to pressing the button before the conscious mind decided to do it. Noah didn't know anything about these studies. He only knew that he preferred one brand of cereal over the other. What he didn't see was the chain of unconscious signals firing in his brain before the thought even reached his awareness. His hand had begun to move toward the box while his conscious mind was still telling itself a story about choosing. Later that day, Noah met his friend Lily at a cafe. As they sat down with their drinks, she told him about a recent breakup. She said she'd spent weeks agonizing over whether to end the relationship. She believed the final decision had come in a flash of clarity during a late-night walk. But her brain had been preparing for that choice long before she recognized it. Tiny moments, a harsh word, a disappointed look, an unmet expectation, had been recorded and processed beneath her awareness. By the time she decided, the groundwork was already in place. Her conscious mind simply gave the final push and claimed ownership. The brain does this constantly. It takes in vast amounts of information every second, far more than we can consciously process. Most of it never reaches awareness. Instead, unconscious networks handle the heavy lifting, sorting through signals, weighing options, and setting up actions. Conscious thought arrives late to the party, like a narrator who explains what just happened, rather than directing the story. Noah noticed this himself on the drive home. As he sat in traffic, his foot tapped the brake at just the right moment when a light turned red. He didn't think about it beforehand. His body reacted, and only afterward did he realize what he'd done. Driving often works this way. Experienced drivers don't consciously plan each small movement. Their brains run the process automatically, with conscious thought stepping in only when something unusual happens. This illusion of control runs deep. People believe they're making decisions in real time, but their brains are often several steps ahead. When Noah reached for his coffee cup, his muscles were already moving before he chose to lift it. When he smiled at a joke Lily told, his facial muscles began to react before he felt the emotion fully bloom. Later that week, Noah attended a family dinner. His brother made a teasing comment about Noah's career, and Noah felt anger flare up. He opened his mouth to respond sharply, then stopped himself. It seemed like a moment of willpower, a conscious choice to stay calm. But even this was shaped by unconscious processes. His brain had generated the anger automatically, triggering changes in his heartbeat and breathing. The decision to hold back came from other brain regions that weighed the social cost of snapping. Both impulses rose from deep, hidden systems. Noah's conscious mind only noticed the winner and took credit for it. Psychologists call this post hoc rationalization. The brain makes a choice, and consciousness rushes in to explain it after the fact. This is why people can't always explain their actions clearly. Ask someone why they picked a certain shirt, and they might say, "I liked the color." In reality, subtle factors they didn't notice, lighting in the store, a memory triggered by the fabric, a faint scent of detergent, may have driven the decision. Noah thought about this while walking through the park one afternoon. He passed a couple holding hands and felt a sudden pang of loneliness. The feeling seemed to come from nowhere, but his brain had been building it quietly. A song playing in a nearby cafe, the sight of the couple, and the cool evening air all combined to stir old memories of his last relationship. By the time the emotion reached his awareness, it felt like it had appeared instantly. The same thing happens with cravings. When Noah smelled fresh bread from a bakery, his mouth watered. He told himself he wanted to buy some because he was hungry. But hunger wasn't the whole story. The scent had triggered dopamine release deep in his brain, priming him to seek food. His conscious mind simply wove a neat explanation around the urge. One night, Noah lay in bed, scrolling through his phone. He told himself he would stop after 5 minutes. Half an hour later, he was still scrolling. It felt like a failure of willpower, but in reality, his brain's reward circuits were in control. Each new post or message delivered a tiny hit of dopamine. These automatic processes were faster and stronger than his conscious intention to stop. The more Noah paid attention to his daily life, the more he saw this pattern. Choices he thought were deliberate often appeared automatic in hindsight. He picked up his keys without thinking. He checked his phone whenever it buzzed. He laughed at jokes before realizing why they were funny. His conscious mind took credit, but it was clear that the machinery underneath was running the show. Lily noticed it too. She told Noah about a moment at work when she blurted out an idea during a meeting. She didn't plan to speak. The words seemed to form on their own, and only after everyone turned to look at her did she feel like she had decided to say them. It was unnerving, like watching herself from outside her body. Noah nodded. He'd felt that same strange delay, the sense of being a passenger rather than the driver. It made him wonder how much of his life was truly his own. When he thought back to the cereal aisle, the breakup, the arguments, and even the small daily habits, he saw a pattern. The brain acted first, fast and unseen. Consciousness arrived late, telling a story of choice and control. As he lay awake that night, Noah considered the possibility that free will was less about creating decisions and more about observing them. The thought was unsettling. He liked to believe he was steering his life, but if his brain was making choices milliseconds before he knew about them, then perhaps he was more witness than author. He stared at the ceiling, feeling the weight of this realization. Somewhere beneath his awareness, neurons were firing, preparing his next move. In a moment, he would roll over, turn off the light, and close his eyes. When it happened, it would feel like his decision, but in truth, the choice would already be set in motion, his mind catching up only at the very last second. Clara sat at her grandmother's kitchen table, sipping tea while her aunt told a story from Clara's childhood. It was about the summer when Clara had fallen into the lake at a family picnic. Her aunt described the scene in detail. The shouts, the splash, Clara's terrified face as her uncle pulled her out of the water. Everyone laughed at the memory. Clara laughed too, even though she couldn't recall it herself. Later that night, lying in bed, Clara thought about the story. She pictured the bright sun reflecting off the lake, the taste of lemonade, the rough texture of her uncle's hands gripping her arms. By the next morning, the image felt solid, like a real memory. Weeks later, when someone asked about her childhood, Clara found herself telling the story as if she had always remembered it. She didn't realize that the memory wasn't real. She had never fallen into that lake. The event never happened. The human brain is remarkable at creating vivid images and feelings. It uses these skills to recall past experiences, but the same process that makes memory powerful also makes it fragile. Memories are not fixed recordings. Each time we recall one, the brain rebuilds it from pieces. During that rebuilding, details can shift or disappear. If someone adds new information while we are remembering, the brain may weave it in so seamlessly that it feels authentic. Clara's aunt hadn't meant to deceive her. She had simply misremembered, mixing Clara's childhood with another cousin's. But once Clara heard the story, her brain treated it like a real experience. It filled in gaps with imagination, guided by the details her aunt provided. Within days, Clara could remember the sound of her own scream as she sank beneath the water, even though she had never been in danger. False memories don't feel false. This is what makes them so convincing. When Clara thought about the lake, her heart raced slightly. Her palms even grew damp, as if her body believed the event had really happened. The brain's emotional centers respond to imagined experiences in much the same way they respond to real ones. A fabricated memory can trigger fear, joy, or sadness just as strongly as an actual one. Years later, Clara met a man named James who had experienced something even more unsettling. During a therapy session, his counselor asked about his early childhood. At first, James struggled to recall much. The counselor suggested that maybe James had repressed painful memories. They talked about possible scenarios, gently exploring what might have happened. Over time, fragments began to surface. Images of a dark room, raised voices, a sense of dread. James became convinced that he had been mistreated as a child. The memories felt real and vivid, but when James confronted his family, they were shocked. His parents denied it, and other relatives confirmed their story. Records showed that James hadn't even been in the places he described at the ages he claimed. The memories, though clear in his mind, were false. They had been shaped by suggestion during therapy, growing stronger each time he revisited them. This phenomenon has been studied in laboratories. In one famous experiment, researchers asked volunteers about childhood events. Some questions were about real experiences confirmed by family members. Others were about events that never happened, like getting lost in a shopping mall. At first, participants rejected the false events, but after a few sessions of discussion and gentle prompting, many began to remember them. They added details: what clothes they were wearing, who found them, how they felt. By the end, some participants were certain the fake memory was true. Clara read about this experiment years after her own lake memory took root. It unsettled her to think how easily the mind could be tricked. She realized that arguments with her sister about past events might not have been about who was lying, but about whose brain had rewritten the story more convincingly. False memories aren't always dramatic. Sometimes they are small, like believing you left your keys on the counter when you actually dropped them in your bag. Other times, they have serious consequences. Eyewitness testimony in courtrooms is notoriously unreliable for this reason. A witness might be confident and sincere, yet completely wrong. Stress, leading questions, and the passage of time all make memory malleable. One evening, Clara watched a news story about a man who had spent years in prison for a crime he didn't commit. The key evidence had been the victim's identification of him as the attacker. She had been certain she saw his face. Later, DNA evidence proved his innocence. The woman wept on camera, saying she still remembered his face vividly, even though she now knew it wasn't him. Her brain had built the memory around trauma and suggestion, and once it solidified, it felt as real as any true event. Clara thought about her own mind and how many memories she carried. She wondered how many of them were accurate. She remembered a birthday party where she swore there had been a clown, though no one else recalled one. She remembered a vacation where she could picture herself holding a red kite, even though photographs showed the kite had been blue. These weren't lies. They were the natural result of a brain that edits the past each time it retrieves it. One summer, Clara visited the lake from her childhood story. She stood on the dock, looking at the water. In her mind, she could still see her younger self slipping beneath the surface, hear the splash and the shouts. The memory was so clear it felt impossible to doubt. Yet she knew the truth now. She had never fallen in. Her aunt had mixed up the story, and Clara's brain had done the rest. As she stood there, she felt a strange mix of emotions. The false memory had shaped her life in small ways. For years, she had avoided deep water, feeling uneasy at pools and beaches. She had even taken extra swimming lessons as a teenager to overcome her fear. All of that had been built on something that never happened. Clara sat on the dock, dipping her toes into the cool water. She thought about how fragile memory really was. Each person walks through life carrying a private collection of stories. Some are accurate. Others are stitched together from imagination, suggestion, and fragments of truth. No one can tell them apart by feeling alone. The false ones live alongside the real ones, just as vivid, just as convincing. When Clara left the lake that day, she felt a quiet sense of wonder and unease. She couldn't change how her brain worked. She couldn't stop it from rewriting the past. All she could do was remember that not every memory she held was a window to the truth. Some were just stories her mind had created, as real to her as the splash of water she never actually felt. Liam sat on the edge of his bed, staring at the floor. The room was quiet, but he couldn't shake the feeling that someone was there with him. His heart raced as he glanced at the corner near the closet. At first, he saw only shadows. Then, slowly, a figure seemed to form. It was tall and dark, its face hidden. Liam froze, unable to move or speak. He blinked hard, and the figure vanished. The room looked normal again, just a messy pile of clothes and a pair of old shoes by the closet door. Liam ran his hands over his face, telling himself it wasn't real. But deep down, he wasn't sure. It had felt real. The sight of it, the way his skin prickled, the rush of fear in his chest, all of it had been as strong as any real-life experience. Liam hadn't always lived like this. 2 years earlier, he was a college student with plans to become a graphic designer. He had friends, hobbies, and a busy life. The first sign that something was wrong came one night when he was walking home from the library. He thought he heard someone whisper his name. He spun around, but no one was there. The street was empty. He laughed it off, blaming stress and lack of sleep. Over the next few weeks, the whispers returned. At first, they were faint, like the rustle of leaves. Then, they grew louder. Sometimes they said his name. Other times, they spoke words he couldn't quite understand. Liam started sleeping less, afraid of what he might hear when the world went quiet. His friends noticed he was distracted, but he brushed off their concern. One afternoon, as he sat in a lecture hall, he heard a voice, clear and sharp, as if someone were sitting right beside him. "You don't belong here," it said. Liam jerked his head around, but the seats nearby were empty. He left the hall and didn't return to class that day. Hallucinations like these come from deep inside the brain. For reasons scientists don't fully understand, certain circuits begin to misfire. The brain produces sounds or images with the same intensity as real ones. To the person experiencing them, there's no clear line between perception and imagination. Liam's auditory cortex, the part of the brain that processes sound, lit up as if there were truly a voice speaking to him. His fear was not imagined. His body reacted exactly as it would if a real person had been whispering threats in his ear. Liam tried to explain this to his best friend Caleb one evening. They sat on Caleb's couch while Liam described the voices. Caleb frowned and said maybe it was anxiety or depression. Liam nodded, pretending to agree, but he didn't believe it. Anxiety didn't make you see shadows moving across the walls or hear footsteps following you home. The worst part came when the voices began to argue with each other. Sometimes they fought about him. Other times, they mocked him directly. "You're worthless," one hissed. "You'll never make it," another sneered. Liam covered his ears, but the voices didn't fade. His own brain had turned into a trap, feeding him lies that felt like truth. As the illness progressed, Liam started withdrawing from his friends. He skipped classes, stopped answering texts, and spent most of his time in his apartment. He taped over the mirrors because sometimes his reflection didn't look like him. Once, while washing dishes, he saw the reflection in the window smile, even though his face hadn't moved. He dropped the plate, shattering it across the sink. Schizophrenia often appears in young adults, striking just as they're building their futures. It doesn't announce itself with a clear warning. Instead, it creeps in, blurring reality bit by bit. Liam's parents thought he was just going through a rough patch. They urged him to get more sleep, to eat better, to focus on his studies. None of it helped because the problem wasn't outside him. It was inside his brain. One night, Liam sat at his desk, trying to draw. His sketchbook lay open, but his hand wouldn't move. The voices were loud that evening, taunting him. Then, without warning, he heard his mother's voice calling his name. It was so clear, he nearly leapt from his chair. She lived 3 states away. There was no way she could be there, yet the sound was unmistakable. Tears filled his eyes. If his own mind could mimic his mother's voice so perfectly, how could he ever trust what he saw or heard again? The next day, Liam went to a campus counselor. He struggled to explain what was happening, afraid she'd think he was making it up. She listened carefully and suggested he see a psychiatrist. After several tests and long conversations, he was diagnosed with schizophrenia. The doctor explained that his brain was misinterpreting signals, creating false perceptions that felt real. Medication helped quiet the voices, but they didn't disappear entirely. Therapy taught Liam strategies to cope when hallucinations broke through. Even so, some days were overwhelming. At the grocery store, he sometimes heard strangers muttering insults that weren't there. On the bus, he might see someone glaring at him, only to realize the person wasn't looking at him at all. One afternoon, Caleb visited Liam for the first time in months. Liam hesitated to let him in, worried that Caleb would see the taped-over mirrors and the stacks of untouched mail. But Caleb just sat with him and listened. Liam told him about the figure by the closet, about the voices that filled his nights. Caleb didn't try to fix anything. He just stayed. For the first time in a long while, Liam felt a small spark of connection. Liam's illness didn't fade away. Some mornings he woke up to silence and sunlight and almost felt normal. Other days, he woke to whispers and shifting shadows. He learned to question his senses, to pause before reacting. If he heard someone call his name, he looked around carefully and waited before answering. He told himself that not everything his brain produced could be trusted. Living like this was exhausting. The line between real and unreal was thin and fragile. Liam missed the days when he could rely on his mind without doubt. But those days were gone. His own brain had become both ally and enemy, giving him life while also twisting it. One night, as he lay in bed, he heard a soft voice say, "You're safe now." It sounded like his mother again. Liam closed his eyes, unsure whether it was real. The comfort it brought was real enough, and for a moment, that was all he had. Evan sat alone in his apartment, staring at the half-empty bottle on the table. He told himself he wouldn't drink tonight, that he would stay in control this time. The thought felt solid, like a promise. But as the minutes passed, his hand moved almost on its own. The first sip brought a rush of warmth and relief. His shoulders loosened, his mind quieted. For a brief moment, everything felt right. When Evan first started drinking, it was casual. Weekends with friends, celebrations, nothing serious. Back then, 1 or 2 drinks gave him a pleasant buzz. But over time, he needed more to get the same feeling. Nights out turned into nightly rituals alone. He told himself it was just stress, just a way to relax after work. What he didn't realize was that his brain was changing, piece by piece, with every sip. Addiction doesn't just live in habits, it lives in the structure of the brain. Substances like alcohol, nicotine, or drugs hijack the brain's reward system. This system evolved to keep humans alive, encouraging behaviors like eating, finding shelter, and forming relationships. When Evan drank, alcohol triggered a surge of dopamine, the chemical that signals pleasure and motivation. His brain registered this as a powerful reward, much stronger than anything natural. The first few times, it was just chemistry doing its job. But with repeated use, his brain began to rewire itself. Neural pathways strengthened around drinking. Cells in his reward system became more sensitive to alcohol cues, like the clink of ice in a glass or the smell of whiskey. These cues started firing before Evan even took a sip, flooding his mind with craving. One evening, Evan walked past a bar he used to visit. He hadn't planned to go in. He was just heading home after work. But the sound of laughter and the sight of golden light spilling from the doorway hit him like a wave. His heart raced, his mouth watered, and his steps slowed. By the time he realized what was happening, he was already inside, ordering a drink. His decision hadn't felt like a decision at all. It felt automatic. That's the trap of addiction. Over time, the brain begins to prioritize the addictive behavior above everything else. To Evan's brain, drinking became as vital as food or water. Other parts of his life, his job, friendships, health, faded in importance, even when he swore he wanted to stop. His neural circuits pushed him back toward the bottle. Evan's friend, Maya, struggled with a different addiction. She didn't drink, but she spent hours each night glued to her phone, scrolling through social media. She told herself it was harmless, but the constant stream of likes, notifications, and videos worked on the same dopamine circuits as Evan's alcohol. Each ping of her phone delivered a tiny hit of pleasure, reinforcing the habit. One night, Maya deleted her social media apps, determined to break free. By the next morning, she was re-downloading them, her hands trembling with anticipation. Like Evan, she wasn't weak or lazy. Her brain had been rewired to crave the behavior. Neural pathways don't distinguish between substances and actions. Gambling, gaming, even compulsive shopping, all of them can hijack the reward system. For Evan, the consequences grew worse. He started missing work, lying to friends, and hiding bottles around his apartment. Each time he promised to quit, his cravings overpowered him. His brain had learned to expect the surge of dopamine from drinking. When it didn't come, he felt restless and sick. This withdrawal wasn't just emotional, it was physical, as his brain's balance of chemicals tried to reset itself. One morning, Evan woke up on his couch with a pounding headache and a dry mouth. Empty bottles littered the floor. He didn't remember drinking that much, but his body told him the truth. His hands shook as he reached for another drink, not to get drunk, but to stop the shaking. This was when he understood that he wasn't just drinking because he wanted to. He was drinking because his brain demanded it. In therapy, Evan learned how addiction changes the brain's structure. The prefrontal cortex, which helps with decision-making and self-control, weakens with repeated substance use. This made it harder for him to resist impulses, even when he knew the harm they caused. Meanwhile, the reward system stayed hyperactive, always scanning for signs of alcohol. His therapist compared it to a car with a stuck accelerator and failing brakes. The engine roared with desire, but the system meant to slow it down was too weak. No amount of willpower alone could fix that imbalance. Recovery meant more than just stopping. Evan had to retrain his brain. Each day without drinking was like carving a new pathway, slowly weakening the old ones. It was exhausting work. Some nights he sat on his hands to stop himself from grabbing his keys and driving to the liquor store. Other nights, he walked for hours through dark streets, trying to outpace the craving. Maya went through her own struggle. She set strict limits on her phone, only to break them repeatedly. She realized her patterns weren't about the apps themselves. They were about how her brain lit up every time she felt connected or validated. Understanding this didn't make it easier, but it gave her a framework. Like Evan, she had to build new routines, replacing mindless scrolling with activities that brought real satisfaction. Both of them learned that relapse wasn't failure, it was part of the process. Each slip revealed how deeply their brains had been altered. Neural circuits built over months or years don't disappear overnight. They fade slowly, like old trails in a forest growing over with weeds. One evening, Evan walked past that same bar again. The laughter and golden light still stirred something inside him, but this time he kept walking. His craving didn't vanish, but he noticed it without acting on it. That small victory felt like a glimpse of freedom. Later, he sat with Maya in a quiet cafe. They talked about their struggles, the late-night urges, the frustration, the slow progress. They both understood that addiction wasn't just about choices, it was about brains that had been reshaped by repetition and reward. As they sipped their coffee, Evan thought about the first time he had tasted alcohol. Back then, it had felt harmless, even fun. Now he knew that each sip had been more than a moment of pleasure. It had been a message to his brain, a signal that grew louder and stronger until it drowned out everything else. He still wanted to drink sometimes. The urge didn't disappear. But for the first time, he could see the craving for what it was, a circuit firing, not a command he had to obey. That understanding gave him a fragile but powerful sense of control. It was the start of a new path, one he would have to walk every day, one step at a time. Emma sat at the bus stop, watching cars glide past in the fading light. She glanced at the sign across the street, reading it without thinking. The letters seemed clear and solid. She didn't question whether her brain was showing her the real world. It felt obvious that what she saw was simply there. But deep inside her skull, something very different was happening. Her eyes weren't cameras taking perfect pictures. They sent fragments of light and color to her brain. Scattered and incomplete. Nerves carried signals, but they were just electrical pulses, meaningless on their own. Emma's brain stitched them together, filling in gaps and smoothing rough edges. The seamless world she experienced was more like a guess than a photograph. As she waited for the bus, a man walked past, and for a split second, Emma thought she recognized him as her old teacher. She blinked and saw a stranger instead. The switch was instant. In that moment, her brain had made a prediction based on past memories. It didn't pause to check the facts. It filled in what it expected to see. The illusion broke only when new information proved it wrong. Most of the time, this process goes unnoticed. When Emma looked at the red car across the street, her brain wasn't receiving red directly. It was interpreting wavelengths of light and comparing them to stored experiences. If a shadow passed over the car, making the color darker, her brain automatically corrected it. She didn't see the raw change, She saw a stable image created for her convenience. Later, as the bus arrived and she climbed aboard, Emma sat by the window. The city rolled past in a blur, yet her mind turned the chaos of motion into a smooth, coherent scene. Each glance gave her only a small portion of the street. The rest, her brain invented. It guessed where buildings continued behind other objects. It assumed that the parked cars stayed the same shape even when half hidden. Without these assumptions, the world would appear broken and confusing, like a puzzle missing pieces. One evening, Emma experienced this more vividly. She was home alone, reading on the couch, when she thought she saw a spider crawl across the edge of her vision. She gasped and jerked her head toward it. Nothing was there. Her brain had stitched together a false image from random flickers of light and expectation. The feeling of fear was real, even though the spider wasn't. This wasn't unusual. The brain constantly fills in empty spaces with its best guesses. When Emma walked through her dark hallway at night, she didn't see complete darkness. She saw shapes and outlines created by her mind. Sometimes these shapes became threatening, imaginary figures lurking where there was only a coat on a hook. She knew logically that the coat was harmless. But her primitive circuits didn't wait for logic. They generated a picture to keep her alert, just in case. Emma's friend, Daniel, told her about a strange experience he had once. After a long day without enough sleep, he drove home and briefly saw a stop sign that didn't exist. It wasn't a vague blur. It was crisp and detailed, like every real sign he'd ever seen. His brain had predicted what should be on that corner and produced it on his windshield. When he reached the intersection and found nothing there, he felt unsettled. Illusions like this happen because perception isn't passive. The brain doesn't sit back and wait for perfect data. It works ahead of time, predicting and adjusting. Most of the time, these predictions are accurate. They create a smooth, stable reality that helps people move through the world efficiently. But sometimes the brain guesses wrong. When that happens, the mistake feels just as real as the truth. Emma noticed this one afternoon while listening to music through old headphones. The sound crackled, and part of a lyric dropped out. Without thinking, her mind filled in the missing word. She only realized it later, when she looked up the lyrics and discovered she'd been wrong. Her brain had inserted something that wasn't there, and she hadn't noticed it all. The same thing happened with touch. Once, while sitting at her desk, Emma felt a light tap on her shoulder. She turned, expecting to see a coworker. No one was there. It was only the fabric of her sweater shifting as she moved. Her brain had taken incomplete signals from her skin and built a story around them. The story felt true for a split second, even though it wasn't. These constant predictions go beyond simple errors. They shape every moment of experience. When Emma watched a movie, she didn't notice the individual frames flashing on the screen. Her brain blended them into continuous motion. When she listened to a familiar song, her mind anticipated the next note so strongly that she sometimes heard it before it actually played. One winter morning, Emma walked through a park covered in fresh snow. The world seemed calm and beautiful. But her brain was busy filling in details she couldn't actually see. She assumed the snow was smooth beneath the surface, even though only the top layer was visible. She assumed the bare trees were still standing solidly out of sight. These assumptions let her navigate without hesitation, but they were still guesses. Later, a friend showed her a photo of the same park taken from a different angle. In the picture, one of the trees she thought she'd seen was missing. She realized she hadn't truly seen it at all. Her brain had placed it there because it expected it to be there. Emma thought about how much of her life was built on these invisible processes. Every face she recognized, every street she crossed, every word she read was the result of countless predictions. Her mind wasn't giving her a raw feed of reality. It was presenting a carefully constructed version, cleaned up and filled in. Sometimes these constructions broke down. When Emma was tired or distracted, she made more mistakes. She once waved at a friend across a crowded cafe, only to realize it was a stranger. The embarrassment burned, but it wasn't really her fault. Her brain had matched a vague outline to a familiar pattern and presented it as fact. At night, when Emma lay in bed with her eyes closed, she noticed faint patterns swirling behind her eyelids. They weren't real objects, but her brain still tried to make sense of them. This same process happened during the day, hidden behind her open eyes. One evening, Emma and Daniel sat on a balcony, watching the sunset. Daniel mentioned his stop sign hallucination again. Emma told him about the spider she'd seen that wasn't there. They laughed, but then fell silent, thinking about how fragile their senses were. The world felt solid and dependable, yet it was mostly built inside their heads. They weren't just observing reality. They were actively creating it, moment by moment, filling in gaps with stories their brains invented. The stories felt seamless. They felt true. As darkness settled over the city, the lights blurred into glowing shapes. Emma blinked, and for a second, she couldn't tell whether the shapes were real or imagined. It didn't matter. Her brain was already working to smooth the edges, to hand her a picture she could live in, a picture that would always be part truth and part hallucination. Sophie sat at the kitchen table with a cup of tea growing cold in her hands. The morning sun streamed through the window, casting warm light across the room. It should have felt safe and peaceful, but she couldn't shake the sense that something was wrong. A faint headache throbbed behind her eyes, and a strange unease sat heavy in her chest. She didn't remember making the tea, though the cup was in front of her. She didn't remember sitting down either. She stood up quickly, her chair scraping the floor, and walked through the apartment. The bed was unmade, her coat was on the floor by the door, and a stack of dirty dishes filled the sink. It looked like she'd been living her life on autopilot. That happened to her sometimes. Whole hours would vanish, replaced by blank spaces in her memory. She used to think she was just forgetful, until she began noticing things that were harder to explain. One afternoon, she opened her journal to find a page filled with handwriting that wasn't quite hers. The words were sharp, the tone angry. The message read, "Stop pretending everything is fine." Sophie stared at it, her hands trembling. She lived alone. No one else could have written it. Over time, other signs appeared. A scarf she didn't remember buying appeared in her closet. Groceries she hadn't purchased filled her fridge. Sometimes, when she looked in the mirror, she felt like the reflection wasn't entirely her own. It was as if someone else was looking back at her through her own eyes. When she finally saw a therapist, she struggled to describe what was happening. The therapist listened carefully and suggested that Sophie might be experiencing dissociation. This happens when the mind disconnects from certain memories, feelings, or parts of the self. In Sophie's case, it had gone further. The therapist explained that extreme trauma, especially in childhood, can cause the mind to split into different identities. Each one carries a part of the pain or fear that the original self couldn't handle alone. Sophie thought back to her childhood. Her memories were fragmented, full of holes. There were long stretches of time she couldn't recall. She knew there had been fear and violence, but the details slipped away whenever she tried to grasp them. It was like trying to remember a dream that dissolved as soon as she woke up. One evening, after an especially difficult session, Sophie sat in her living room and felt an odd sensation, as if someone were standing just behind her shoulder. A wave of dizziness washed over her, and then silence. When she came back to herself, the room was darker. The clock said 2 hours had passed. On the table in front of her was a half-eaten sandwich she hadn't made. Her phone contained a message to her therapist that she hadn't sent. The words in the message were calm and polite, unlike the fear she felt inside. Her therapist helped her begin to identify the different parts of herself. There was a voice that carried her anger, one that held her sadness, and another that seemed focused on keeping her safe at any cost. These weren't separate people in the literal sense. They were parts of Sophie's mind that had become so distinct they sometimes acted independently. When one took control, the others faded into the background. Sophie began to notice small shifts in her body language and speech. Sometimes she sat hunched and quiet, barely whispering. Other times, her tone became sharp and confident. Friends commented on these changes, asking if she was feeling okay. She usually laughed it off, but inside, she felt a deep confusion. One night, she recorded herself during one of her blackouts. When she played back the video, she saw herself pacing the room and speaking in a voice that sounded different from her usual one. The words were firm, protective, and even kind. Watching it made her stomach knot. She didn't recognize the person she saw, yet she knew it was still her. The human brain develops this way as a form of survival. When a child faces overwhelming trauma, like abuse or neglect, the mind can't process it as a single whole. Instead, it separates the pain into compartments. This allows the child to keep functioning. One part goes to school and plays with friends, pretending everything is normal. Another part hides the terror and grief. Over years, these divisions grow stronger until they feel like entirely separate identities. Sophie's therapist explained that these identities aren't enemies. Each one formed to protect her in some way. The angry voice fought back when she couldn't. The calm, polite voice soothed others to prevent conflict. The quiet, fearful one stayed hidden to avoid danger. Together, they had kept her alive. As Sophie worked through therapy, she began to hear the different voices more clearly. Sometimes during a session, she would feel herself drift to the back of her mind while another part spoke directly to the therapist. It was disorienting, but also strangely relieving. For the first time, she understood that the blank spaces weren't empty. They were filled with pieces of her life she hadn't been ready to face. One weekend, Sophie visited her sister, who had lived through some of the same childhood experiences. They sat in the kitchen, drinking tea, and Sophie cautiously brought up her memories. Her sister's eyes filled with tears as she nodded. She remembered things Sophie didn't. Their stories didn't match perfectly, but they overlapped enough to confirm what Sophie's mind had buried. That night, Sophie had a vivid dream. She stood in a dark hallway, and doors lined each side. Behind each door, she sensed a different presence. Some were angry, some were scared, and one was silent. She woke with tears on her face, realizing the dream reflected her inner world. Over the next few months, Sophie practiced staying present during moments of stress. She learned grounding techniques, touching a textured object, naming things she could see, listening to the sound of her breath. These small actions helped her stay connected when she felt herself slipping into dissociation. But progress was slow and uneven. One evening, after a particularly stressful day, she woke to find herself standing on a street she didn't recognize. Her shoes were wet, and a bus ticket was crumpled in her pocket. Panic surged through her. She had no idea where she had been or what she had done. She called her therapist, who reminded her that this was part of the process. Recovery didn't mean erasing the other parts of herself. It meant learning to communicate with them, to bring them into balance. In time, Sophie began to sense when a shift was coming. She could feel the subtle signs, a change in her posture, a sudden wave of emotion that didn't match the moment. She would pause, breathe, and remind herself that all of these parts were still her, even when they felt separate. One quiet afternoon, she sat at her kitchen table again, tea in hand. The room looked the same as before, but Sophie felt different. She still didn't have all her memories. She still sometimes lost time. But now, when she looked into the mirror, she saw not just one face, but a reflection of many selves, each carrying a piece of her story, each proof that she had survived. Ellen sat in the living room with her younger brother, laughing over old photos spread across the coffee table. The images showed birthdays, vacations, family dinners. She smiled at a picture of herself as a child, standing on a swing set, her hair in messy braids. It looked like a perfect day, but as she stared at the photo, she felt a strange tightness in her chest. She couldn't remember the rest of that afternoon, no matter how hard she tried. Her brother pointed at another picture and asked, "Do you remember this? You fell and scraped your knee." Ellen shook her head. She didn't recall falling. She didn't recall the day at all. She shrugged it off and said, "I guess I was too young." But she wasn't that young. She should have remembered. That night, Ellen lay in bed, uneasy. It wasn't just that one missing memory. There were entire stretches of her childhood that felt hazy and out of reach, like fogged glass. She'd always told herself she just had a bad memory. Yet lately, she'd been having flashes, sudden images or sensations that came without warning. A door slamming, a man's angry voice, the smell of sweat and dust. They vanished as quickly as they appeared, leaving her shaken. The mind has ways of protecting itself from harm. When something unbearable happens, the brain sometimes buries it. This process, called repression, isn't a conscious choice. It happens automatically. Like a safety mechanism, the memory doesn't disappear, but it's pushed out of awareness so the person can keep functioning. It's like locking a painful object in a box and shoving it deep into a dark closet. As a child, Ellen had learned to ignore certain things. When fights broke out in her house, she would retreat to her room and hum to herself, drowning out the noise. She didn't think of it as survival. She just knew it helped her feel safe. Over time, she got so good at pushing things away that entire events seemed to vanish. Years later, as an adult, the buried memories began to surface in strange ways. Ellen started having vivid nightmares. She would wake up gasping, with no clear image of what she'd dreamed, only a lingering sense of fear. Certain sounds made her heart race for reasons she couldn't explain. She snapped at friends over small things and felt guilty without knowing why. One afternoon, she was walking past a construction site when a piece of wood fell with a loud crack. In that instant, Ellen felt like she was 6 years old again. Her knees buckled, and she gripped a nearby fence, trembling. She couldn't explain what had just happened. It was as if her body remembered something her mind refused to see. Ellen finally decided to see a therapist. At first, she talked about stress at work, her troubled relationships, her restless nights. The therapist listened carefully and asked gentle questions. Over time, Ellen began to notice patterns in her reactions. Certain topics made her go quiet. Certain words made her hands clench into fists. One day, while describing an argument she'd had with her partner, Ellen stopped mid-sentence. A flood of images rushed into her mind: her childhood bedroom, the swing set from the photo, and a shadowy figure standing in the doorway. She gasped and pressed her hands to her face. Tears came, but no words followed. Her therapist explained that these fragments were signs of a repressed memory surfacing. The brain hides these memories because at the time of the trauma, facing them would have been too much. A child doesn't have the tools to process overwhelming pain or fear, so the mind locks it away. Years later, when life feels safer, the brain may start to release pieces of the past. The release isn't neat or orderly. It comes in flashes, dreams, physical sensations. A smell or sound can act as a trigger, unlocking the old memory unexpectedly. The person may not even realize why they're reacting so strongly. Ellen began to piece together her past slowly, like assembling a shattered mirror. She remembered her father's sudden rages, the way she'd hidden in closets or under blankets. She remembered the sting of harsh words, the sharp smell of alcohol on his breath. Some memories remained blurry, as if her mind wasn't ready to let them in fully. One evening, Ellen told her therapist about a recurring dream. In the dream, she was in her childhood home, running down a hallway that seemed to stretch forever. No matter how fast she ran, she never reached the door at the end. The therapist suggested that the dream reflected her struggle to face the truth. Part of her still wanted to keep it locked away. As Ellen explored these buried memories, she began to notice how they shaped her present life. Her fear of confrontation wasn't random. It came from years of walking on eggshells as a child. Her tendency to avoid intimacy wasn't a flaw in her character. It was a defense, built to protect her from being hurt again. Defense mechanisms like repression aren't weaknesses, they're survival tools. Without them, Ellen might not have made it through her childhood. The mind had shielded her until she was strong enough to face the truth. But there were costs. The hidden memories leaked out through anxiety, nightmares, and sudden bursts of anger. They influenced her choices without her realizing it. By keeping the truth buried, she had been living in a story with missing chapters. One weekend, Ellen visited her brother again. They looked through more photos, and this time, she asked questions. Her brother was surprised by how much she didn't remember. Together, they filled in some blanks. Some of what he told her matched the fragments she'd been uncovering in therapy. Other details were new, painful, and hard to hear. As she drove home that night, Ellen felt a mix of sorrow and relief. The truth was heavy, but it was also hers. It had been hidden for so long that facing it felt like reclaiming a lost part of herself. Later, sitting alone with a cup of tea, Ellen thought about the photo of the swing set. She could still see the bright sun, the braided hair, the frozen smile. Behind that image lay a whole world she hadn't been allowed to see as a child. Now, slowly and carefully, she was opening the locked box inside her mind. Each memory she retrieved was painful, but it was also a step toward wholeness. The tea had gone cold by the time she set the cup down. She sat quietly, breathing, and let herself remember. Caleb scrolled through his phone, his thumb moving at a steady rhythm as headlines flashed by. Most of them didn't hold his attention, but when he saw an article that matched what he already believed, he stopped immediately. The title made him feel a rush of satisfaction, like proof that he had been right all along. He didn't read the whole piece carefully. He didn't check the source. He just skimmed the opening paragraph and nodded, convinced. When Caleb came across an article that challenged his view, he felt a different kind of rush. His pulse quickened and his jaw tightened. Without even thinking about it, he searched for flaws in the argument. A missing detail, a suspicious statistic, a writer he didn't trust. Once he found even a small reason to doubt it, he dismissed the entire thing. His brain moved on as if it had never been there. This was confirmation bias at work. Caleb didn't know the term, but he lived it every day. His brain wasn't an impartial judge weighing evidence. It was more like a lawyer, building a case for what it already believed to be true. The facts that supported his worldview were highlighted and reinforced. The ones that didn't were ignored or torn apart. Later that week, Caleb argued with his friend Leah about a local election. Leah believed strongly in a different candidate. The two of them sat in a coffee shop, voices rising, each certain they had the stronger case. Caleb cited articles and studies he had read. Leah countered with her own sources. What neither of them noticed was that they were doing the same thing, collecting evidence that supported their side while discarding anything that didn't fit. When Caleb got home that night, he replayed the conversation in his head. He remembered the points where Leah had hesitated, the moments where he felt he had won. He didn't notice the times when her arguments had been stronger than his. His memory wasn't lying exactly, but it was reshaping the story to protect his sense of being right. This pattern didn't just show up in politics. It appeared in smaller, more personal ways. Caleb once suspected that his coworker, Jenna, disliked him. After that thought took root, he started noticing every little thing she did that could be interpreted as cold or dismissive. If she didn't say good morning, he saw it as proof. If she frowned during a meeting, he assumed it was directed at him. When she was kind or helpful, those moments faded quickly from his memory. His brain filtered them out because they didn't fit the narrative he had already built. Confirmation bias is powerful because it feels natural. When Caleb read an article that matched his beliefs, the sense of rightness felt like evidence in itself. He didn't pause to ask whether the information was accurate. His brain rewarded him with a burst of certainty, a little rush of dopamine that encouraged him to keep seeking more of the same. This became especially clear when Caleb joined a group on social media filled with people who shared his views. The group felt like a safe space, a place where everyone understood him. They posted articles, memes, and personal stories that reinforced each other's opinions. Over time, Caleb's confidence grew. He wasn't just convinced he was right, he was certain that anyone who disagreed was ignorant or malicious. Then, one afternoon, a friend sent him a well-researched article that contradicted something Caleb believed deeply. Caleb opened it reluctantly and skimmed a few paragraphs. The evidence was strong, the sources solid. Still, his first reaction wasn't to consider it carefully. It was to defend himself. He felt attacked, even though the article didn't mention him at all. His brain worked quickly to find reasons to dismiss it. Maybe the writer had an agenda. Caleb scrolled through his phone, his thumb moving at a steady rhythm as headlines flashed by. Most of them didn't hold his attention, but when he saw an article that matched what he already believed, he stopped immediately. The title made him feel a rush of satisfaction, like proof that he had been right all along. He didn't read the whole piece carefully. He didn't check the source. He just skimmed the opening paragraph and nodded, convinced. When Caleb came across an article that challenged his view, he felt a different kind of rush. His pulse quickened and his jaw tightened. Without even thinking about it, he searched for flaws in the argument. A missing detail, a suspicious statistic, a writer he didn't trust. Once he found even a small reason to doubt it, he dismissed the entire thing. His brain moved on as if it had never been there. This was confirmation bias at work. Caleb didn't know the term, but he lived it every day. His brain wasn't an impartial judge weighing evidence. It was more like a lawyer, building a case for what it already believed to be true. The facts that supported his worldview were highlighted and reinforced. The ones that didn't were ignored or torn apart. Later that week, Caleb argued with his friend Leah about a local election. Leah believed strongly in a different candidate. The two of them sat in a coffee shop, voices rising, each certain they had the stronger case. Caleb cited articles and studies he had read. Leah countered with her own sources. What neither of them noticed was that they were doing the same thing, collecting evidence that supported their side while discarding anything that didn't fit. When Caleb got home that night, he replayed the conversation in his head. He remembered the points where Leah had hesitated, the moments where he felt he had won. He didn't notice the times when her arguments had been stronger than his. His memory wasn't lying exactly, but it was reshaping the story to protect his sense of being right. This pattern didn't just show up in politics. It appeared in smaller, more personal ways. Caleb once suspected that his coworker, Jenna, disliked him. After that thought took root, he started noticing every little thing she did that could be interpreted as cold or dismissive. If she didn't say good morning, he saw it as proof. If she frowned during a meeting, he assumed it was directed at him. When she was kind or helpful, those moments faded quickly from his memory. His brain filtered them out because they didn't fit the narrative he had already built. Confirmation bias is powerful because it feels natural. When Caleb read an article that matched his beliefs, the sense of rightness felt like evidence in itself. He didn't pause to ask whether the information was accurate. His brain rewarded him with a burst of certainty, a little rush of dopamine that encouraged him to keep seeking more of the same. This became especially clear when Caleb joined a group on social media filled with people who shared his views. The group felt like a safe space, a place where everyone understood him. They posted articles, memes, and personal stories that reinforced each other's opinions. Over time, Caleb's confidence grew. He wasn't just convinced he was right, he was certain that anyone who disagreed was ignorant or malicious. Then, one afternoon, a friend sent him a well-researched article that contradicted something Caleb believed deeply. Caleb opened it reluctantly and skimmed a few paragraphs. The evidence was strong, the sources solid. Still, his first reaction wasn't to consider it carefully. It was to defend himself. He felt attacked. Alex sat on the porch with his sister Leah, watching the sun dip below the trees. They were talking about a family trip they'd taken years ago, a summer vacation to the mountains. Leah laughed as she described how their father had burned the marshmallows while trying to make s'mores by the campfire. Alex laughed too, but as she spoke, something felt off. He remembered that night differently. In his version, it was Leah who had dropped her marshmallow into the flames and cried about it. "No," Leah said, shaking her head. "That was definitely Dad. You even teased him about it for days." Alex frowned. The image in his mind was so vivid. Leah's small hands holding the stick, the smell of burnt sugar, the look on her face. He could almost hear her voice. It felt real, certain. Yet Leah was equally confident in her memory. For a moment, they both fell silent, each clinging to their version of the past. That night, Alex lay awake, replaying the memory. The more he thought about it, the clearer it seemed. But clarity didn't mean accuracy. He didn't know that each time he recalled the scene, his brain was subtly rewriting it. Memories aren't like photos stored in an album. They're more like stories, reconstructed piece by piece whenever we bring them to mind. The first time something happens, the brain encodes it in fragments, sights, sounds, emotions, and facts scattered across different regions. When Alex remembered the campfire, his brain pulled those fragments together and filled in gaps with guesses. Maybe he remembered the smell of smoke from a different night, or the sound of Leah crying from another event entirely. Over time, these details blended until they felt like a single, seamless moment. The act of remembering doesn't just retrieve the memory, it changes it. Scientists call this process reconsolidation. When a memory is recalled, it temporarily becomes malleable, like soft clay. In that state, it can be reshaped by new information, emotions, or suggestions. When the brain stores it again, it isn't quite the same as before. Alex experienced this firsthand a few weeks later when he met an old friend named Marcus. They reminisced about high school, swapping stories of late-night drives and stupid pranks. Marcus mentioned a time they had been caught sneaking into the school gym. Alex laughed and said he remembered it well. The security guard's angry face, the rush of adrenaline as they ran. But Marcus shook his head. "That wasn't you," Marcus said. "That was me and Jordan. You weren't even there." Alex stared at him, stunned. He could picture it so clearly. The red glow of the exit sign, the sound of his sneakers pounding the floor. How could it not be his memory? Yet as Marcus described the night in detail, Alex realized he couldn't pinpoint exactly why he'd been so certain. Maybe he'd heard the story so many times that his brain had adopted it as his own. This is how false memories form, not through lies or deceit, but through the natural way the brain edits and rewrites the past. Each retelling adds layers, like a story passed through many hands. Small changes go unnoticed at first. A detail shifts here. A feeling grows stronger there. Eventually, the original event is buried under a version that feels more real than reality itself. Alex's mother once told him about a Christmas when he's 4 years old. She said he had cried because the neighbor's dog barked too loudly while they opened gifts. Alex had no memory of this, but after hearing her story, he began to picture it. The barking, the smell of pine, the way the wrapping paper crumpled under his hands. Years later, he swore he could remember the entire scene, though he knew he couldn't possibly recall something from that age with such clarity. His mother's words had planted seeds, and his imagination had done the rest. The brain's tendency to rewrite memories explains why eyewitness accounts are so unreliable. Two people can witness the same event and later describe it in completely different ways. Stress, suggestion, and time all play roles in reshaping what they believe they saw. In courtrooms, this can lead to devastating consequences. A witness may testify with absolute certainty, unaware that their memory has been altered by repeated questioning or the influence of others. Alex thought about this one afternoon when he ran into Leah again. She brought up the campfire memory, insisting once more that Dad had burned the marshmallow. Alex hesitated. His own memory was still strong, but Marcus's correction about the gym incident had shaken him. What if Leah was right this time? What if his vivid image of her crying by the fire was just another story he'd told himself over the years? He decided to test himself. That night, he dug through old family photos and found one from the camping trip. In the picture, their father stood by the fire, holding a marshmallow stick and laughing. Leah was in the background, smiling. The photo didn't prove everything, but it supported her version more than his. Alex stared at it, feeling a mix of relief and discomfort. His memory hadn't just been wrong. It had been convincing, detailed, and emotionally charged. It felt like part of him. Letting go of it felt like losing a piece of his own life. Over the next few days, Alex noticed how often people around him talked about the past with total confidence. A coworker insisted that a meeting had gone a certain way, while another swore it had been completely different. Friends argued about who had told a joke first, each certain they remembered correctly. It struck Alex that they were all probably wrong in some way, though none of them would ever know for sure. Memory isn't a perfect record. It's a living, breathing process shaped by the present as much as the past. When Alex recalled the campfire now, he could almost feel the original image fading, replaced by the version supported by the photo. The smell of burnt sugar lingered, but Leah's tearful face blurred and slipped away. One evening, Alex sat alone with his thoughts. He wondered how many of his memories were quietly shifting each time he replayed them. The first kiss he ever had, the last conversation with his grandfather, the day he graduated. Were those moments as they truly happened, or had they been polished and edited over the years? The more he considered it, the more fragile his past felt. Each memory was like a painting touched up by unseen hands. The colors brightened, the shapes subtly altered. It was still his painting, still his life, but the original strokes were gone. When Leah called the next day, she mentioned another childhood trip. Alex listened carefully, noticing how his mind instantly began to form images, filling in blanks with guesses. He smiled to himself, aware now of the trick his brain was playing. The memories felt real, warm and vivid, even as they shifted beneath his feet like sand on the shore. Ethan sat in a crowded cafe, scrolling through his phone while waiting for his coffee. The room buzzed with chatter, the hum of conversation blending with the hiss of the espresso machine. A man in a bright red jacket walked past his table and dropped a set of keys with a loud clink. Ethan didn't notice. His eyes were fixed on the screen, and his mind was locked on a text message from work. The man bent down, picked up his keys, and left. It wasn't until the barista called Ethan's name that he looked up, startled by how much time had passed. Later, when a friend asked if the cafe had been busy, Ethan described it as quiet. In reality, there had been a small argument at the counter, 2 people hugging near the door, and a server spilling milk on the floor. He hadn't seen any of it. His focus had been so narrow that the rest of the world vanished. The human brain works like a spotlight. It shines bright on whatever task or thought feels most important, leaving everything else in darkness. This selective focus helps people function in a world full of information. Without it, the noise and chaos would be overwhelming, but it comes at a cost. When attention locks onto one thing, other things, even obvious ones, fade into invisibility. Ethan learned this in a dramatic way a few months later. He was helping his friend move apartments, carrying boxes back and forth. At one point, his friend handed him a box and said, "Watch out for the step." Ethan nodded, but didn't really hear him. He was too focused on balancing the heavy box. A moment later, he stumbled over the step and nearly dropped everything. His friend laughed and said, "I warned you." Ethan realized he hadn't even seen the step, though it was right there in front of him. This is what psychologists call inattentional blindness. It doesn't mean the eyes aren't working. Ethan's eyes had taken in the image of the step, but his brain hadn't processed it. Attention decides what information gets noticed, and anything outside that focus can vanish as if it never existed. There's a famous experiment where people are asked to watch a video of players passing a basketball. The task is to count how many times one team passes the ball. In the middle of the video, a person in a gorilla suit walks through the scene, beats their chest, and walks away. Nearly half the viewers don't see the gorilla at all. They're so focused on counting passes that their brain filters out everything unrelated to the task. Ethan heard about this experiment from his sister, who was studying psychology. He didn't believe it until she showed him the video. He watched carefully, counting each pass with intense concentration. When the video ended, his sister asked, "Did you see the gorilla?" "What gorilla?" he said, genuinely confused. She replayed the clip, and there it was, the huge, undeniable gorilla in the middle of the screen. Ethan felt a chill. If he could miss something so obvious, what else was he missing in his daily life? He started paying attention to moments when his focus narrowed too much. While driving, he noticed how easily he tuned out everything except the car in front of him. A billboard might flash by. A pedestrian might wave, but if it wasn't directly related to staying in his lane, his brain discarded it. That's why so many drivers claim they never saw the cyclists they hit. Their eyes took in the scene, but their attention was elsewhere. One evening, Ethan walked home after dark, listening to music through his headphones. A neighbor later told him they had waved and called his name from across the street, but he hadn't responded. He hadn't even noticed. His brain was wrapped in the song's rhythm, the lyrics filling his thoughts. The world outside might as well have been muted. This filtering happens because the brain has limited resources. It can't fully process every sight, sound, and sensation at once. Instead, it prioritizes. The chosen details get processed into awareness. The rest are stored faintly or not at all. This is why two people can share the same experience and later describe it completely differently. Each person noticed different things, and each one is certain their version is the full story. Ethan saw this play out during a dinner party. Two friends argued about where a bottle of wine had been placed earlier in the evening. One swore it had been on the counter. The other insisted it had been on the table. Both were sure they were right, but when they checked, the bottle was in a cabinet neither had mentioned. Their memories weren't lies. They were simply built on incomplete perception. As Ethan thought more about this, he began to see how much of reality is constructed. When he walked through the city, his brain gave him a sense of a complete, detailed world. But in truth, he was only noticing small pieces. The sound of a passing bus, the sight of a shop window, the feeling of the pavement under his feet. These were the highlights his mind selected. The rest of the environment faded into a blur. One Saturday, he sat in a park and tried to widen his focus. He listened carefully, noticing birdsong, distant laughter, the buzz of insects. He looked at the grass, seeing individual blades instead of a single green patch. Within minutes, he felt overwhelmed. There was too much to take in. His brain wanted to narrow the spotlight again, to simplify the world into something manageable. Ethan realized how dangerous inattentional blindness could be. A driver looking at their GPS might miss a child running into the road. A doctor focused on one symptom might overlook a more serious problem. A witness to a crime might fail to see the person standing right beside them. These weren't failures of vision, but failures of attention. One rainy night, Ethan crossed a busy street. He reached the other side and turned to glance back. Only then did he notice a bicyclist who had swerved sharply to avoid him seconds earlier. He hadn't seen the bike at all when he stepped off the curb. His heart pounded as he understood what had almost happened. The next day, he told his sister about it. She nodded and said, "That's how it works. We think we see everything, but we don't. Most of the world just disappears." Ethan thought about that long after their conversation ended. The world felt solid and certain, but his experience of it was full of holes. Every moment, his brain chose what to show him and what to hide. He wondered what he had been missing all his life. What gorillas had walked through his world unseen while he counted something else. Mara sat by the window of a quiet cafe, stirring her coffee even though she didn't plan to drink it. She had just had an argument with her friend Jonah, and her thoughts spun in circles. "I can't believe I said that," she muttered to herself. "That's not who I am." The words felt comforting, like a way to separate her action from her identity. But as she sat there, the question nagged at her. Who exactly was this I she kept talking about? Later, on her walk home, she thought about the fight again. She replayed it in her mind, editing the details without realizing it. In one version, Jonah's tone was sharp and dismissive, making her anger seem justified. In another version, her own words sounded softer, kinder than they probably had been. Each replay smoothed the edges of her story, turning a messy argument into a clear tale about a reasonable person wronged by someone else. The strange thing was that Mara believed these edits. Her brain didn't mark them as changes. It simply rewove the event and handed it back to her as truth. This was how the brain works every day. It doesn't just record what happens. It constructs a story, one where the main character is always you. From the moment Mara woke up each morning, that story began to unfold. I am tired. I need coffee. I have to get to work. Each thought felt like a report from a stable, unchanging self. Yet if she looked closely, there was no single thing to point to. Her moods shifted throughout the day. Her opinions changed depending on who she was with. The I in the morning didn't feel quite like the I at night, but her brain stitched them together into one continuous thread. When Mara was a child, she thought of herself as shy. In high school, she reinvented herself as outgoing and bold. As an adult, she now saw herself as calm and thoughtful. Which of those versions was the real her at the time? Each one had felt completely true. It was as if she'd worn different masks and then forgotten they were masks at all. One evening, Mara flipped through an old journal she had kept at 13. She barely recognized the voice on the pages. The girl who had written those words seemed like another person entirely. Yet Mara's brain told her it was still her, part of one unbroken line of identity. The narrative smoothed over the gaps and changes, pretending there had always been one continuous self. Jonah once told her about a man he met at a hospital where he volunteered. The man had suffered a stroke that damaged part of his brain. Afterward, he couldn't form new memories. Every few minutes, he would reintroduce himself, convinced it was the first time he was meeting Jonah. Yet when Jonah asked him about his life before the stroke, the man told detailed stories. He described his childhood, his career, his family. He sounded like a whole, consistent person. Jonah explained that even though the man couldn't hold on to the present, his brain still built a narrative from the fragments it had. It didn't matter that those fragments were incomplete. The story felt real because the brain's job is to create meaning, to keep the illusion of a solid self alive. Mara thought about this for days. She began noticing how often she explained her choices to herself after the fact. When she picked up a blue scarf at a store, she told herself it was because she liked the color. Later, she realized she had grabbed it automatically, without thinking. The explanation came afterward, like a narrator scrambling to make sense of a random event. She started catching herself in the act. When she turned down an invitation, she heard herself think, "I need rest tonight," even though, deep down, she wasn't sure if that was true. Maybe she was avoiding a difficult conversation. Maybe she just didn't feel like going. The story she told herself wasn't necessarily false, but it wasn't the whole truth either. It was a way to keep her sense of self tidy and consistent. One weekend, Mara visited her parents. Her mother told a story about Mara's childhood, laughing at how stubborn she had been. "You've always been like that," her mother said. Mara smiled, but inside, she felt strange. She didn't remember the event at all, yet her mother's version slid easily into her own narrative. Within hours, it felt like a real memory. She could almost see herself as a little girl, crossing her arms and refusing to budge. That night, lying in her old bedroom, Mara realized her personal story wasn't hers alone. Other people contributed to it: parents, friends, teachers, even strangers. Their words became part of the I she believed in. The self wasn't a single, solid thing. It was a collage of voices, stitched together so seamlessly that she couldn't see the seams. The next day, Mara went for a run in the park. She focused on her breathing, on the rhythm of her feet hitting the ground. For a brief moment, her thoughts went quiet. There was no narrative, no I telling a story. There was just movement, breath, and sunlight. It didn't last long. Soon, her mind began chattering again. I should run faster. I'm almost home. I need to shower before work. The story resumed, as it always did. Later, she met Jonah to talk about their fight. As they spoke, Mara noticed how her brain worked to frame her words. She wanted to be the hero of the story, the reasonable one. Jonah wanted the same for himself. They weren't just discussing facts. They were both editing reality to protect their identities. On the walk home, Mara thought about how fragile the whole thing was. If her memories could be rewritten, if her moods could shift from one hour to the next, what did it really mean to have a fixed self? Maybe the I wasn't something solid she carried inside her. Maybe it was more like a novel being written in real time, each page influenced by the ones before, but never fully determined. She stopped by a bookstore and wandered through the aisles. She picked up a novel and flipped to the middle. Without context, the page made little sense. Characters appeared and vanished, their motives unclear. Only by reading from the beginning could she see how the story held together. Her own life felt the same way. At any given moment, her brain gave her just enough narrative to make sense of things. It didn't matter if the past was distorted or the future unknown. The illusion of a continuous self was enough. When Mara reached home, she sat by the window with her now cold coffee. She watched her reflection in the glass and wondered who exactly was looking back. The face was familiar, the thoughts inside her head constant and loud. Yet beneath it all, she sensed something quieter. A vast space where stories rose and fell, each one temporary, each one pretending to be the whole truth.